Hey guys, welcome. I'm Brandon and I've been making videos to help people get into game development for almost 2 years now. I have dozens and dozens of bite-sized tutorials on my channel, but I've been wanting to do something really in-depth that is for beginners. So if you were interested in game dev, but you have never made anything, you've never opened a game engine before, then this is the perfect video for you. So this video is not a series of lectures that's going to give you a whole bunch of boring theory before you actually get started. What you can expect is a cozy and low stress video where I go unscripted during the entire thing and you and I will make an Angry Birds clone together. I wanted this to feel almost like you had a friend or a coworker sitting right beside you, showing you the ropes for how to make games. I do take the time to explain everything as we go, but really you're going to be learning by getting your hands dirty and building a game that works on your PC, and later on we'll do a refactor so that it works for mobile as well. Angry Birds is a perfect game to make a copy of because it's fun, but it's also involved enough that we're going to have to learn a whole bunch of different things that you're going to need to know if you want to know how to make games. You will learn how to use the Unity game engine. You're going to learn how to write C# code, detect input, use the engine's physics system, handle camera transitions, create particles, play sounds, handle different game object collisions, add friction or bounciness to game objects. You're going to learn UI, how to build levels with prefabs, simple scene management by loading in new levels, and many other little tips and tricks along the way. Now, this is not meant to be done in one sitting. I have broken the video into 10 to 20 minute chunks, and each of those chapters can be thought of as self-contained lessons because really we're just going to be doing 1 or 2 things throughout those lessons, and I'll talk you through the whole process. So grab a hot drink, relax, take your time when you go through this. Just focus on learning when you're going through the video because by the end, you're going to be in a really good place to be able to start making games. I built this in a fairly simple manner on purpose because I really remember my first Unity tutorials. And what I really remember is how quickly everything can start to feel really overwhelming. I had a lot of questions and I had a lot of trouble going through and following through tutorials. So I very much made this video with all of that in mind. You are in very good hands here, I promise, and you are going to be shocked by how much you have learned by the end of this video. And as you can imagine, making a video this long took quite a lot of work, and everything is always a gamble when you post it on YouTube. I'm not sure if the length of this video is going to make people run for the hills or not, but if you want a way to thank me or support this channel, we do have a Patreon page that'll give you access to some exclusive content, including the source files for all the tutorials ever made on this channel. There's also YouTube thanks if that suits you better, and we actually just opened up a game dev merch shop as well. That's another great way you can support us and get something cool in the process. So there are several ways that you can support this channel, but please only do so if you are actually able to afford it. If you want to thank us but you cannot do it that way, a great way that you can do it for free is just by giving this video a thumbs up. It really does make a difference with the YouTube algorithm, and you can go ahead and drop a quick comment down below because that kind of engagement really also does help to boost these kinds of videos in the YouTube algorithm. What I really want is to help as many people as possible start their game dev journey and make it as pain-free as possible. Now, whether you're wanting to get into it professionally or as a hobby, it doesn't matter because you have to start somewhere. And if you are a hands-on learner, then this video will be worth your time investment. And with all of that said, let's get started. You ready? Let's go. Hey guys, welcome. I am so excited to be able to show you your very first game in Unity, and I want to go ahead and jump right in. So if you're wanting to get into game development, I'm going to go ahead and assume that you are smart enough to know how to install Unity yourself, so I'm not going to show you how to do that. Go ahead and Google it and download Unity Hub. Unity Hub is what you want, okay? So once you've done that, what you're going to see is this on your screen here. This is Unity Hub. And the difference between Unity Hub and Unity itself is Unity Hub is just what it sounds like. It's a hub that allows you to install different versions of the Unity editor. It can sometimes be common to need more than one type of Unity installation. You can actually see right here, I've got my editor version. I've got Unity version 2022.3.17. And down here, I've got a couple of different other ones, right? So once you have downloaded and installed Unity Hub, in here, you're going to want to go to installs. And these are my 2 that I've installed. You're going to want to go to official releases, and you're going to want to click install editor. So what I would recommend, especially if you were just starting out, just pay attention to the LTS versions. Those stand for long-term support. With Unity, you get the option of doing either the really latest and greatest stuff, which is going to be the other versions down here. This is the latest and greatest, but that means that it might have some features that are experimental or still in development. Long-term support is generally the more stable for production version that you're going to want to use. So for all tutorials, I like to stick with LTS versions. So they've got a long-term support right now as of recording for 2021 and 2022. Go ahead and install the LTS version of the most recent one, whichever one pops up for you. Okay, once you have that done, we're going to go ahead and create a new project. We're going to go over here and go to projects, and we're going to create a new project. So what that's going to do is bring up a whole bunch of different template sets here. I'm just going to take off my jacket here. I'm already warm and I've just started. So like I said, there's a whole bunch of different templates, and Unity has what is called different render pipelines, but that's outside the scope of this tutorial. I'm not going to get into that right now. But what I would say is if you're working in 3D, you're going to want to go ahead and open up a 3D URP one. And if you're working on a 2D game, which we are in this tutorial, we're going to make Angry Birds, then we're going to click 2D URP. Let's go ahead and call this something like Angry Birds, just because I already have a project called Angry Birds. And I'm going to disable Connect to Unity Cloud and go ahead and click Create. And if you want to go ahead and get yourself a hot drink, now is the perfect time. This usually takes a minute or two. I've got one right here. Okay, and here is what you are eventually going to be greeted with. This is the Unity engine. So we've got a couple of different windows that I should explain to you, but first I want to show you that you are able to click and drag each individual window. You can rearrange this however you want. You can move stuff around. You know, I can even put this up here and just make this left side really large. You get it, right? You can move stuff around, but don't worry about like messing it up and not being able to put it back to the way you want, because you can go to layout over here and you've got a couple of default options here. My preferred one that I like is 2x3. This is the one that I always start out with, but I like to move my project over here and then drag this up. And here's your icon sizes. You can drag that around. I like them to be nice and small because we end up usually with a large amount of assets in our projects. So this window right here, this is the scene view. This is where you're actually going to be dragging things in, and this is going to be a representation of your game. You can look around in this view in 3D and in 2D. And once we get some actual sprites and assets going in, then we'll see them all here and we'll actually move them around and place them. So this is where you basically build your game, is in the scene view. The game view down here, this is what it will actually look like when you play your game. So I always like to have the scene view and the game view open at the same time, because when you hit play, they're both going to open, which is really, really nice. This is your hierarchy window here, and this is what our scene is going to be composed of. You can see if I click that little drop down arrow there, what we have in our scene right now is a camera and a light. That is it. That's just the default 2D universal render pipeline, which is the 2D URP that we selected. Every new project that you set up is going to have a main camera and a global 2D light if you select 2D URP. Now you'll notice on the right side over here, it completely changes depending on what I click on over here in my hierarchy. That's because this is the inspector window here. So this is where we're actually going to be changing a whole bunch of different values and adding components to GameObjects. And we're going to be talking about that. Don't worry about what GameObjects are just yet. We'll get there. But that is where we'll be assigning different values. We're going to be changing a whole bunch of different things, adding components, etc., etc. When you start creating scripts, you're going to drag and drop them, and you're going to work with them over here in the inspector. For example, you can see this box here that represents my camera size. I can drag around the size here, and that's just going to go ahead and change it. So this allows you to manipulate a lot of different fields. And this down here, this is your project window. And this is going to be basically a representation of your actual folder structure on Windows or on Mac if you're using Mac. So these are our actual different folders and our actual different asset files. And that's a good place to end it right there, actually, because I want to actually get some assets in here right now. So when you want to get assets into your project, you're going to drag and drop them into your project folder down here. So I'm actually going to go ahead and right click and create a new folder, and I'm going to call it Sprites. All right, now I'm going to leave a link down below for every single asset that you're going to see in this video if you want to use them, but I do just want to put a quick disclaimer in here. I'm using the actual Angry Birds assets from Spriter's resource, and it's worth mentioning that these are the property of Rovio. They're obviously not mine. I didn't make them. I'm simply using their assets because I thought it would be much more fun to do it this way than using some other garbage assets from some other website. So I'm dragging in my sprites right now from my folder, but again, I'm going to leave you download links down below so that you can download all of these yourselves as well. Okay, so once you've downloaded these, we're all in the same place now. Here's the interesting thing, okay? When we look at these, I want to actually open one in Windows here. Sometimes, a lot of the time when you're working in 2D, you're going to get what is called a sprite sheet. That is what this is. This is a sprite sheet, meaning it is a PNG that contains a whole lot of different sprites that you're going to want to use for your game. Sometimes you will have individual sprites, and that's totally fine, but sometimes you're going to be working with sprite sheets like this. So every single asset I think that we're using is from a sprite sheet here. So what we need to know is how are we actually going to grab individual sprites from there? So first thing I want to do is if you hold shift and you click at the bottom here so that you select all of them, I want to turn the filter on these sprites off. The default is bilinear. I want to turn that to point, which means no filter. That's just going to make sure that the actual pixel art is, Unity's not going to do anything behind the scenes to kind of blur the edges to make them smoother. I don't want any blurriness going on. So click apply when you've done that. So I am going to fast forward through this here, but I will show you all of the different sprites that we're going to want to cut up. But one more thing we want to change for all of them, if we select all of them again, you'll notice the sprite mode up here is set to single. That is always the default for the sprites, and that's assuming that you brought in a sprite that's just one sprite that you want to use, okay? But in this case, we brought in sprite sheets, so we want to change this to multiple instead, and we're going to go ahead and click apply. That's going to allow us to actually cut these up. So I'm just going to go through these one by one. So we're going to click on this one and click Sprite Editor over here. So there was actually only one button I wanted from this one, and it was this guy right here. So literally just click and drag, and you'll see this nice little green box. And I just want to cut it to the very pixel. So you can zoom in as far as you want. Just drag that little blue line until you get it where you want it. And do that for all four sides. Okay, so once you've got it the way you want it, go ahead and click apply. Now you'll notice once we did that, there's now this little arrow here. If we click down on that, we now have, if I bring this up here, it's actually created just that one sprite that we just cut out. So that is perfect. And now actually, if we wanted, just to show you as an example, we could drag this right into our scene view over here or into our hierarchy over here, right? That's just going to center it. So now we've actually cut it up into a usable sprite, but I don't want that in my project just yet. I want to cut all of these out first. So moving on down to the next one, I'm going to go to the sprite editor. And this one, again, it's actually literally just this one thing that I wanted. I wanted to grab this congrats text. Okay, that's good. Go ahead and click apply. All right, next one. Okay, I actually want 3 on this one. I want the sky. By the way, I'm doing all of this with the mouse wheel. I don't know if I mentioned that, but if you hold down the middle mouse button, you can just pan around like this and scroll it forward and backward to zoom in and out. And now I'm going to take this grass too as well. Okay. All right, the characters. Couple of things we want from here. Definitely want our bird. And a piggy. This part of the slingshot. And this part of the slingshot. And they separated it so that you can layer it. It'll make sense really soon. And I'm also going to grab these 4 smoke rings here. Okay. I accidentally brought in the same sprite sheet twice. I don't know why I did that, so I'm just going to delete this one. And nice selection here. I'm just going to grab a few at random, I think. Okay. There we go. So that was some boilerplate work that we had to do in order to actually get this project set up. Now I'd like to actually set up our environment, like put the sky and the ground and the grass and all that good stuff in there. So that's this one here. So if we drop that down, and if you want to be able to see them, you can increase it like this. Let's bring our sky in first. So literally you just drag that right into your hierarchy up here. Okay, so it's too small, and that's totally fine. So remember that our inspector over here shows whatever we are selecting in the hierarchy right now. So right now I'm going to go ahead and rename this right now to sky. So this here, this is not a sprite by itself. Okay, I know we dragged a sprite into the hierarchy, but what we did is we actually created what's called a game object in our hierarchy. So what is a game object? I will create a blank one right now. If you right click and click create empty, that's going to create a brand new game object that has literally nothing in it. You can see it in our scene view. It has arrows that we can move around, but it's invisible. It's nothing. It's literally just an invisible nothing in our game world, which has a position, a rotation, and a scale. That is literally it. Every single game object has to have a transform component. Whenever you create one, it's automatically going to have a transform. You cannot remove it. The option to remove it's not even here. So the way that this actually works is we have game objects that have different components on them. So you'll see that our sky right here has what's called a sprite renderer component on it. Now I could have done the exact same thing with this empty game object we just set up right here. I could say add component, and I could add a sprite renderer to it. And renderer means it's going to put it on the screen. It's actually going to display something. Now we have a sprite renderer. It's still invisible, but that's because we haven't assigned a sprite to it. I could drag that sky sprite in there, and now we've actually got a sky game object. It's exactly the same thing. That is what dragging and dropping this sprite into our hierarchy did. It was just a shorter way of doing that. When you drag a sprite in, it knows, Unity is smart enough to know I'm going to go ahead and add a sprite renderer because they want to display a sprite. So I'm going to add a sprite renderer component and assign this sprite down here from the project window. So we have our sky game object with a sprite renderer with a sprite attached to it. So that's fantastic. So how do we make it bigger? That is in our scale right here. We want to scale this up. So you can change one axis at a time if you want, but I don't want to do that. I want to enable constrained proportions here. So by clicking that, and actually you can go to the letters right here. You'll notice these two little arrows pop up. You can actually just click and drag. You don't have to type values in because that's really slow. You can click and drag these values just like this if that's what you want to do. So I'm actually going to bump this to about just 4. 4 should be totally fine. Now, why 4? Because I can still see the edges right here. Well, here's the really, really cool thing about Unity and about these assets that we downloaded. These are tileable assets, which means they are repeatable. We are able to repeat these. So if I actually go to my draw mode here and change it from simple to tiled, I'm now going to be able to change the width on this sprite, and I can just keep going and going and going and going. And if I zoom out on my scene view here, you'll actually see what that's doing. It's literally just repeating it over and over and over and over. So I'm actually going to drag this out to be like 150, honestly. We're going to be shooting a bird, and he's going to be going pretty far, so we want to make sure that we've got sky covering the whole level. Okay, perfect. So there's our sky, and it's tiled. So you already learned about game objects, you already learned about sprites, and you already learned about tiling, which is awesome. So I'm going to go ahead, and by the way, all the assets in this project, they're all, at least the environment assets, they're tileable. The ground is tileable, and the grass is tileable, which is fantastic. So I'm going to go ahead and drag in our ground object here. I'm going to rename that to ground. And I'm going to scale this up to about 2. Now, here's the thing. You can, I want to move this down, right? So you can, enter something on the Y. You can type it in. You can drag the Y here. Or my preferred method is in the scene view here, you can actually just, if you have the object selected in the hierarchy, you're able to move it around, right? Using these arrows here. And by the way, if the arrows are not showing for you, it's probably because you have one of these different viewing tools selected instead. So we've got a whole bunch of different ones here, right? We can, if we click on the rotate, then we can rotate this if we want. Control Z to undo, by the way. The hand tool, all that's going to do is pan around your scene. You're actually not able to interact with game objects and move them around using this tool. But this is the move tool, which is probably the most common one that you're going to have on. So anyways, I would like to move this down to, I don't know, maybe about here. Actually, maybe a little bit more. And again, I would like to tile this. So we're going to change the draw mode from simple to tiled. And I'm going to drag the width out to about the same as the sky, 150. Now I'm seeing some lines here on my game mode and on my scene view. So that's happening because I didn't splice these exactly right. So I'm actually going to go back in and re-splice them so that I can correct that. So I'm not entirely sure what I did wrong here. I'm wondering if I bring this over one more that way. What the heck is this? We can't see our ground, right? What's going on? Well, here's a really good opportunity to show you what the order in layer does. With sprites, there's no perspective, right? There's no depth, so it's just a whole bunch of pictures overlapping on top of each other. So what Unity will use is this order in layer number here so that it knows which ones we want to display first. So our sky, we definitely want the ground to be in front of the sky, so we want to bump up the order in layer on our ground right now. And actually, I want the sky to be in the very back. So actually, I'm going to set that one to a -10, and I'm going to make our ground a -7. And there's a method to my madness here. We're going to have a whole bunch of different sprites, and they all need to have a bunch of different orders. So I've just got them written out over here in a way that makes sense. So the lower your order in layer number is, the further behind it's going to appear behind everything else. So sky is going to be our lowest at -10. But anyways, it does look like I fixed our tiling issue on the ground. I don't see any lines anymore, so that's fantastic. So now I would also just like to add the grass. So we scaled our ground up to 2, so I'm going to do the same thing with the grass to make it match. I'm going to pull it down, probably about there. And this one, I actually want to set its order in layer to 10. There's a few things in the game that I want this to appear in front of, right? And again, we want to tile this. We're going to change it to tiled. I'm just going to put 150 in there. Perfect. So we've got our sky, we've got our ground, and we've got our grass. By the way, you might have noticed that we've got these warnings over here, and we've actually got one showing down here as well. If we have errors, they will be red. If we get warnings, they are yellow. So this is saying that the sprite tiling might not appear correctly because the sprite used is not generated with full rect. So I've never had any issues tiling stuff this way, but if you do want this warning to go away, we can go over here and we can actually change the mesh type to full rect. And let's hit apply. Now you can see that warning is gone, but it's not gone from down here. So any errors or warnings or debug logs, which you'll end up seeing probably, are going to appear down here, and they can get quite annoying. So I want to show you how to get rid of those. So we're going to go to Window, General, and open up your console. Okay, that's going to open up this new window like this. We actually want to dock this somewhere. So again, you click on the little box here. I always like to put my console up here beside the scene view. Okay, so we had a couple of different warnings going on. So we can just hit clear because we've now fixed that. And I'm going to click on my scene view again. So again, it's always a good idea to have your console here because you always want to be able to know what kind of errors and warnings you've got going on. Anything like that will be displayed in the console. And I'm going to rename this to grass. So let me show you something really cool. Sky, ground, and grass are all game objects. I already explained that. But game objects can have child game objects. Let me show you. Our hierarchy can get messy really, really quickly if we're not careful about how we organize it. So I'm going to create an empty game object called environment. And what I'm going to do is drag my sky, ground, and grass inside of environment, right? Now we've got this nice little drop down here. So all of these are now child objects of the environment game object. What does that mean? Well, you can think of it like a folder structure, like you can just put things inside for organizational purposes, and that's fine, but it does do a lot more than that, because if I select that, you'll notice, right? It's not just a folder because it has a transform on it. So if I select environment and I start moving it around, it's going to move the sky, ground, and grass all at the same time. So knowing how to parent your different game objects together can actually save you a lot of time when it comes to building levels. For example, if you're making a 3D scene and you've got hundreds upon hundreds of trees, and you want to shift them around a little bit, or you've moved your landscape and now you need to accommodate your trees and move those over, you do not want to be doing those one at a time. You want them all to be parented to a trees game object and move all of them at once. So that's going to help keep us organized, but it also helps keep development easier down the line. Okay, now I would like to build the slingshot. So let's create a new game object for that. I'm going to call it slingshot. Now, this is going to have a lot of different components and different parts to it. So I'm going to use this as the parent game object, and I'm going to create another game object inside of it called Sprites. So it's inside this one. Okay, so I'm going to drag in this one and this one. All right, so this is our right side. And this one's our left side. So sometimes you'll see these annoying little icons here, and those are gizmos. This one here is actually generated because of our global light 2D. It's just an icon to represent where the light is. You'll see if I disable the light, then that little icon disappears, but that's not what we want to do. If you want to just be able to quickly work in the scene view without those icons getting in the way, there's a little toggle over here called toggle visibility of all the gizmos. We want to deselect that so that they go away. All right, so I just want to position these and scale them up to 2. So I've got a couple of choices here. I could individually increase the scale of each of the slingshot sizes, right? Or I could do the parent up here. I could just go ahead and do it once, right? And that automatically increases it for both of them. Sometimes using the rect tool here is easier when you're working with sprites because you can literally just click on them and drag them around. You don't need to worry about the arrows. So sometimes it is easier to work with that, especially with sprites. So I'm just trying to line this up in a way where it doesn't look weird. All right, I think that'll do it. Now I'm just going to take the parent object here and I'm going to move that to where I want it. It was like somewhere over here. Now I do like that I've got the grass on top of the slingshot here. I do want to make sure that we set these orders to an order that makes sense because we're going to want our bird to be in front of one of them, but not in front of the other one. So the right side, which is this side here, we're going to set that to 9. The left side, we're going to set to 11. So again, all of these order and layers, like it's going to make sense once we actually have the game fully working. But it's the kind of thing where sometimes as you're going through a project, you just kind of need to tweak them as you're going. You don't need to know what they are right from the start of the project. So don't worry about it too much right now. Okay, so we are ready to write our very first script because the next thing that we want to do, we've got our environment all set up, we've got the slingshot in here. Now I actually want to be able to click in here and start dragging some elastic bands back so that we can, shoot the bird forward. And in order to do that, we need a script. And just to tell you really, really high level, remember we talked about game objects, each having different components on them, right? I have no idea what just happened there. Something just kind of bugged out for a second, but anyways, I'm all good now. I changed this to full high definition over here anyways, because I like that better than free aspect. Free aspect is just, it is what it sounds like. It's like, it'll let you see as far as your window is, right? It's just going to keep on getting bigger and bigger. I don't know why it seems to be having problems when I drag that around, so I'm just going to go ahead and stop doing that and change this to full high def instead. But again, we were working with GameObjects, and I told you that they're going to have different components. There are many, many, many kinds of different components that you can add to GameObjects. They're all categorized right here, right? There's different audio components you can add. There are different physics components that you can add. There's a whole bunch of different built-in stuff in Unity that's really going to help you make your game much more easily. But in order to actually control certain aspects of the game, we write scripts, meaning we're going to actually write some code now. Now, a code is going to be attached to a game object just like a component. We're going to drag and drop it on here, and it's just going to be its own separate little thing. So when we write a script, we are basically creating a custom component. So what I would like to do is I'm going to create a new folder called scripts. Each individual code asset file that we create, we call a script. So I'm going to create one. So we're going to go to create and click C# script. We are working with C# in Unity. It's a great programming language. And we're going to call it slingshot handler. So it takes a second, it loads, it does its thing, it compiles, but then it's going to be done. And you're going to see in the inspector, it's going to show us a little preview of the code file that it's generated. There's always a little bit of boilerplate code that gets thrown into every single script, but this is, you know, not going to do anything right now. But what I would like to do is go to our slingshot here and actually drag and drop the slingshot handler onto it. Now we have added a script component to our slingshot. So right here, or here, whatever you want, I just generally like to do it from here. You can double click that in order to open the script up in Microsoft Visual Studio if that is what you chose to install with Unity. So if this is your very first time that you're working with code, congratulations. This is a really, really, really big step in your game development journey. And this is one of the most intimidating things to learn, but it's actually, you're about to see, it's not as bad as it seems. There is going to be a lot of stuff that you might not understand right away. I will take the time to explain everything, but even if you don't understand it, that is okay. It's going to take some time for all of this stuff to really, really sink in and click for you. There's a lot of different stuff to remember, but I have a lot of faith in you. Now, this is not as simple a tutorial as it could be. I could have made this really, really, really bare bones, but I wanted this to be a really fun project that any of you deciding to follow along with would be very proud of when you were finished, because it's actually got some polish elements. It looks really good by the end. So this is probably a little bit more in-depth than your general introductory code video, okay? But I have a lot of faith in you guys, and we're going to explain along every step of the way. So you're in good hands, I promise. So what the heck do we have here? This is the boilerplate code that goes into every single script that you create in Unity. You can change that, but that's advanced stuff, or at least intermediate stuff. We're not going to worry about that right now. So as of right now, the default, this is going to be generated in every single new script that you create. So we've got a couple of different things to look at here. We've got these using statements up here. These are the three that it always gives you by default. And you can think of these as like libraries. Each one of these is going to allow us access to certain functions and certain actual code that we can use in here. And you will see throughout this project, we will be adding different libraries, or different namespaces is what they're called. We're going to be adding different namespaces throughout the project. But for this script, for right now, this is going to be fine. Now, also, as you can see, we created a script called slingshot handler, and you can see we have a public class called slingshot handler. So every single time you create a script, it is going to create a class with that exact same name. Okay, this is your very first day doing code, so you can think of a class as a script. Okay, you can have multiple classes in a script, but that's beyond beginner stuff, so don't worry about that right now. Generally speaking, 99% of the time, every single time you are working with a class, it's just one class per script file that you're working with always. And public, I'll actually explain that when we get to variables. That's just, that's the access level of this file. Classes are always public by default. Now, what the heck is this over here? Mono behavior, right? So this slingshot handler is inheriting from a mono behavior class in Unity. If you have mono behavior after your class, that means you're literally able to attach it to a game object. You are not able to attach scripts to game objects if it is not a mono behavior script. Now, again, I want to reiterate, if you are a beginner, 95% of the scripts that you are going to create are going to be mono behaviors. When you are making scripts that are not mono behaviors, you're getting into more intermediate and advanced stuff, and I don't want you guys to worry about that right now. So all of this stuff, everything up here, all of this right here, that is stuff that you can just leave. It's automatically generated and you don't need to worry about it. So a class is contained within these curly brackets here. You've got an opening and a starting curly bracket. If I type anything outside of that curly bracket, then it's not going to compile. It's going to give us errors. Everything has to be done within these curly brackets. That is how our engine knows where our code starts and ends. And you will notice with our two different methods here as well, there are going to be curly brackets. Each method as well has an opening curly bracket and a closing curly bracket. So we're going to get into methods really, really soon. So there are two things that you need to know about scripts. One is we are going to be creating what are called variables. Variables store things. Variables are basically like little tiny data containers that you can then change in your code and manipulate. It's going to hold a reference to something that you can then change. And there's all different kinds of variables. You can have a variable for numbers. You can have a variable for a Boolean. A Boolean is a true or a false statement. We'll be using those a lot. You can have variables for every single individual component in Unity. Remember the sprite renderer on our game object? I'll show you it as an example. Up here, I can get a reference to a sprite renderer component. So I'm not going to give you a whole lecture because it's all going to start making sense once you actually start working with them. I just want you to understand the very high level details. That's all. So that's number one. Number one is you're going to be working with variables. And number two is you're going to be working with methods. Methods are actually loops with open and closing curly brackets like this. That's where you actually want to do stuff with your code. If you want to actually make your code do anything, it's going to be within a function. A variable is referencing something, a function is doing something. Now you'll notice that our script here came with two functions built in right away, a start function and an update function. Those are built-in functions from Unity. They're actually from the mono behavior class here. So those are functions that the Unity engine already knows what to do with those. It knows when to run them. So start, it tells you right here, it's called before the first frame update. So start actually runs before the very first frame of your game actually starts running stuff. So anything that you want to initialize, any components you want to grab, all these different things, that can be done in the start function. It knows to do that. The update function, on the other hand, this is called once every single frame. This is a method that loops over and over and over. Unity automatically calls the update function every single frame of the game, whether it's running at 5 frames per second or 120 frames per second or more, it doesn't matter. This gets called every single frame of the game. So this is the kind of method where we're going to be doing things like moving our character, right? Anything where we want it to happen smoothly, we want to move stuff around, we want to rotate it smoothly, scale it up smoothly, whatever it is, that'll be done in the update function. So these are both built-in functions from Unity. Now, the other type of function we're going to work with is functions that we create ourselves. So that's really, really high level what you're going to be doing with scripts. You're going to be working with variables and functions. So just as a habit, I always get rid of all of that stuff, okay? But we are going to want the update function back. So you can actually just type update and your autocomplete, you can just tab and it's going to create a private void update. So again, this is just the update function. I just wanted to get rid of all that other unnecessary text. So we just talked about the update function. We know that this is going to run every single frame of the game. Now, what I actually want to do in this update method is detect if we have clicked our mouse button down around the slingshot, then I want to update these little lines that we're going to have the code create to draw the slingshot for us. So we need to be able to detect our mouse clicks. Now we actually need to get out of the script for a second in order to be able to do that. Now, if you want to save your script, go ahead and do Control S. We're going to be coming right back in here in just a second, but we have to install something first. Okay, Unity is broken up into packages. And what we want to do is install a new package in Unity. So Unity, it has so many different modules and all these different things that it can do, and it doesn't need to take up all that space in every single project that you download. So it gives you the option to install things that you might need as a package. So right now we want to install the input system package. So we want to go to Window and go to Package Manager. And make sure up here in packages, you have the Unity registry selected, and we can go over here and just type input. That's going to have the input system come in. We're going to go ahead and click install. So honestly, basically any project you want to make in Unity, you're going to want to install the input system package. The only reason this does not come pre-installed is because they have an older input system that's already baked in. A lot of legacy projects use that, but this is the new one. This is the better one. It's much better to work with. So this is the one you're always going to want to be using. So if you're creating a project in Unity, install the input system package if you want to be detecting input. And it's a game, so you're going to want to. It's going to ask us if we want to restart the editor. That's standard. Just click yes. And it's asking if we want to save our scene. Yes, we do. Okay, perfect. So that has been installed. So let's go back to our script now. So remember I said that I was going to show you how to add different namespaces up here. We actually need to do that right now because we want to be detecting a mouse click. So we're going to say using Unity engine.input system. Now you put a semicolon at the end here. That's going to be, you're going to get used to that really, really fast. After any normal line of code, you're going to end it. That tells it when the code, when you're done writing the code, it's going to end with a semicolon. Okay. Unless it's a function like this here, update, there's no semicolon. That's because this is a function. It's not an actual line of code within the function. So we are going to do what is called an if statement. Okay. So we're going to type if and then open a bracket. What we're going to do is have this open and close bracket and then an open and close curly bracket like this. Okay. So anything inside of these brackets here that we're going to put in, we're going to say if we detect a mouse click, then if that is true, what's in here will run. Only if this is true. If it is false, it is going to go ahead and skip that statement and just execute all the other code below it. Inside of each individual method, the code is going to run from top to bottom, by the way. So we are going to say if mouse.current.left button.was pressed this frame. Okay. So that is our if statement. We are checking if we have pressed the left mouse button on our mouse. If we did, then any code in between these two brackets is going to run. And let me show you, we'll test that really, really quick. Let's type in debug.log. We're going to open our brackets and we'll just say mouse was clicked. Okay, and remember, this is an actual line of code within our if statement within our method, so we want a semicolon in order to actually end it. So what's going to happen is if we save this script, Control S, if we go back into our game and actually click the play button, we should see this message in our console if we click the left mouse button. Let's get it playing. Yeah, we'll say play focused so that it's not full screen. Let's open up our console over here and click play. It always takes a couple of seconds to get going. But then if you click anywhere within the game view, you're going to see mouse was clicked and it's counting the number of times, right? So we know that we're detecting a mouse click, which is great. We can go ahead and clear that. So obviously we don't want to be displaying a message when we click the mouse button. We want to be actually drawing our slingshot based on where our mouse position is. So how are we going to do that? Well, what I want to do is we're going to create our own method now. We're going to say private. That's the access modifier. You always start either a variable or a function with the access modifier. It's either going to be private or public. There are others, but those are the two that you're mostly going to be using all of the time. Public means that other scripts have access to that function. If you're not sure which one you want to use, then make it private. You can always change it to public later on. It's not a big deal. So we're going to say this is a private function. And if it's a function that doesn't return any value, and you'll see what we mean by that in a little ways down the road, most of the functions you write are going to be void, meaning they don't return anything. It's just a method that executes some code, and that's it. Okay, so private void, and we're going to say draw lines. And we need an open and close bracket, just like our update up there. That's just how functions go. Press enter, and then we're going to open and close our curly brackets. So we have just created our own method. It doesn't do anything yet, but that's a method that we can now use to store some code. So what we want to do down here is, if we are pressing our left mouse button, what do we want to do? We want to draw our lines. Okay, this still isn't going to do anything, but what this is doing here is now, if this is true, we are calling draw lines. So now whenever we click our left mouse button, whatever is in this function is now going to execute. So this is really just a big part of what code is figuring out how to tell the engine when to call whichever function, and then obviously figuring out how to do what you want to do within each function. But that's really it. It's like playing a video game. When you're actually putting all of this stuff together, it's like a puzzle. It's a lot of fun. And I'm so sorry, I called this something that didn't make sense, so this is actually a good thing for you to know. If you don't like what it is called, little time-saving tip here, double-click the name of the method and press Control-R. Okay, that's going to bring up this rename box up here. I actually wanted to call this draw slingshot. Okay, press enter, and there you go. So in order to actually draw the slingshot, we need to be able to draw some lines that start from the slingshot and go to our mouse cursor. So here's how we're going to do that. We're going to leave this script for just a second. In here, I'm going to create another parent game object, and I'm going to call this line renderers. So you might have guessed already, Unity already has a built-in component that lets you draw lines very easily. So I'm going to create another game object inside of this one because we want two of them. We want one from this little prong here and one from this one here. So I'm going to go create. I'm going to call it strip start left. And actually, if you want to go ahead and duplicate that, you can click Control D. That'll duplicate it. Press F2 if you want to rename it quickly, and we're just going to do strip start right. Okay, so the left one I want to be right around here, and the right one I'd like to be right around here. All right, so within here, within both of them actually, we're going to want to create a line renderer component. Go ahead and just type in line renderer and hit enter, and that'll just bring this up right here. So there's a whole lot of stuff going on here. All right, so let me show you what's going on really, really quick. There's a lot of stuff that you can change here, and we're going to change a couple of things. Actually, I want to go ahead and change the order and layer really quick. The left one is going to be 12, and the right one is actually going to be 10. Okay, so what we really care about here is positions. Okay, so right now, it's got 2 points. There's going to be point A and point B, and it's going to draw a line in between those 2 points. So if I type, so right now we're not seeing a line in our scene because they're both exactly at the same point. If I move one of them just by adding something in here, all of a sudden now you see this line here, right? And I can drag that around, and there you go. It's creating a nice line. Now, it's purple, which is a little bit weird because we're seeing a white color right here. That is because there is no material on this line renderer. You'll see right down here under materials, we have no material. So anytime you see this color in a Unity project, that means that there is no material applied to it. So this is just the default color that gets displayed when there's no material. So in order to actually display color and interact with light and all the good stuff that we want our sprites to do, it needs a material. So we don't need to create one, we just need to apply one. There's already a whole bunch that have been created for us. So you can click this little circle icon here, type in Sprite, Now, we don't want to use Sprites default. That's actually the old one. We want to click this little eyeball icon here. We want to do Sprite lit default right here. Okay. Now you can see it's actually a nice white color like we would want. Let's go ahead and add a material to our second one as well. Okay, so this is definitely not the right size of the line that I would want. So let's go ahead and get this looking the way that we want right now. I'm going to click this color over here, and I'm actually going to, here's the color controls down here. We're going to do this as a gradient. So we're going to fade from one color on the left side to one color on the right side over here. So we've got this one selected. I'm going to select my color and click on this eyedropper tool and just steal a color from our slingshot over here. I'm going to do the same thing at the end, but pick a darker one. I might lighten those up a little bit because they're a little hard to see. Great. Okay, it's also way thicker than I would want. So I'm actually going to do 0.25 down here, which is looking a little bit better, but I also want to add a little bit of a curve to it. So what I'm gonna do is drag this down to just under 0.15 here, and then I'm gonna right click right in the middle here and click Add Key. And then I'm just gonna drag that up like this over here. And then I'll put this endpoint over here more at 0.25. So you can see now it's going from thin to thick over here, which is great. And lastly, I want to put some end cap vertices on here. I don't want these to be square on the end. I want them to be rounded. So if we put a 90 here, you'll just see that it's now rounded our edges, which is great. So that's how we get our line looking the way that we want. So actually, let me show you something really cool here. So I want to copy everything we just did to the right side. I don't want to have to do that again. So you can click these three dots here and click Copy Component. And we're going to click on the right one. And we're going to paste component values. That's going to override everything that we just did, okay? Which actually includes the order and layer back to 12. So we wanted the right side to be 10. So let's do that. And now let's go ahead and clear out any positions that we might have put in there because we actually don't want these starting off with a position. We were just doing that so that we could test it out and see how they look. But now we have our line renderer component. So what we're going to do is go back into our script and tell it to manipulate the positions of these lines with code to tell it where to go. That is how we are going to connect our lines from the slingshot to our mouse position. So let's do that. Let's go ahead and go back into our slingshot handler script. Now here's where we are going to need to set up some variables. Whenever we set up variables, you can put them anywhere in the script, but it is good practice. And what you're going to see everywhere, what we all do is we keep them up here at the top above all of our classes. So it's going to be all of your variables and then all of your methods. That's just the standard practice that you want to follow. So just like with our methods, we want to put in our modifier first. And if you're not sure what you want it to be, then you want to put it private, and you can always change it to public later. And again, private means that it's only accessible and changeable within this script. If we make it public, then we can access it and change it from other scripts. So we're going to say private, and we actually want to reference our line renderer component. So we're going to say line renderer, and I'm going to call it left line renderer. Okay, now you'll notice that I named mine with an underscore here. That is just a naming convention that I follow. I am in the habit of doing that, so you do not have to follow that necessarily, but you do want to end up following a naming convention eventually that you are going to be consistent with. You don't have to follow mine. You can Google naming conventions for code. There's a whole bunch of different ones. This is just a habit that I'm in, and I don't really want to break that or go against that, so I'll stay within the habits that I've set. But if the underscores bug you, you don't need to worry about that right now. So we've got our left one, so let's also create another variable for our right one. And it's actually really nice. It's going to fill it in for me. So if I just tab, it'll go ahead and create that for me. So what we said was we want to connect these lines from the start of the slingshot and connect them to our mouse cursor. So what we first need to be able to do is to detect where our mouse is on the screen. So you see up here that we created these two line renderer variables, okay? We are also able to create local variables inside of methods. And you're gonna do that whenever you don't necessarily need to reference it over and over and over. You really only need it within that one method, okay? So you're going to see me create a vector3 here, okay? And you'll notice I didn't put private or public because when you create a variable inside of a method, you don't need a modifier because you can't make it public inside of a method. It's always going to be private inside of a method. That's just how it is. Now you might be asking, what is a vector3? Opening up our inspector again, look at the position on our transform. That is a vector3. Our rotation is a vector3. Our scale is a vector3. A vector3 is an X, a Y, and a Z position. We could also create a vector2 that would just be an X and a Y position. So a vector3 is literally just a variable or a little piece of data that stores three numbers, an X position, a Y position, and a Z position. So we are creating a vector3 and we are calling it touch position. Okay, and we are going to set that to be equal to, we want it to be equal to our mouse position. So how do we do that? So there is a built-in method in Unity to allow you to be able to do this. And we actually do it through our camera. So what we can do is say camera dot main dot screen to world point. Okay, and I'll explain that in just a second. So what we're going to enter here is we actually need to now grab the mouse position and put it inside of these brackets here. So that is going to be mouse.current.position .read value. Okay, and again, don't forget your semicolon at the end. So what the heck is this? What is this screen to world point? Well, our mouse.current.position.read value, that is grabbing the screen position of where our mouse is. Let me go ahead and show you really quick, okay? In our update, and here's how we can test things. I'm just going to put in a debug.log, and we're just going to print what is our mouse.current.position.read value. And by the way, I want to show you something really quickly because we're going to hit play a whole bunch of times and I would like this to go a little bit faster. So we're going to go to edit and go to project settings. And over here in editor, I want you to go down and click on enter play mode options. Select that box and then close this. Okay, that is going to make the game load a whole lot faster. Now, you can use that, you can toggle that on for really any small game project like this one. If you're working on something really, really big and you've got dozens and dozens and dozens of scripts, then you're going to want to research and figure out what that option actually does so that you know when you should and should not be using it. But for a tiny little project like this, it's just going to make this go a lot faster for us. So let's go ahead and hit play. Okay, so now it's spitting out, you can see on the bottom left here, it's spitting out where our mouse is on the screen. And you can see it's actually at the top right, it's just, I can't quite get it there exactly, but it's basically 1920 by 1080, which is the width of our monitor. And if I'm down here at the bottom left, if I can get it positioned, just so it would be 0 on the X and 0 on the Y, okay? And again, our Y is gonna be our height, and over here, it's going to be 1920 on the X again and 0 on the Y. So that is screen position. It's literally the pixel position, I guess, in terms of where the mouse is. That does not help us. That is not the same as a transform position or a world position. Those coordinates would be completely different. We're trying to, with code, tell our lines to follow the world position of the mouse. So that is why we're using screen to world point. That is a Unity built-in function that is attached to the main camera that will allow us to change this into a world position. Okay, so I'm going to go ahead and delete this. Okay, so we have the world position of the mouse, but it's just stored in a vector3 right now. It's not actually doing anything yet, right? So now we want to actually make the lines draw. So we are going to create a method called setLines. Okay, and down here we are going to call setLines. Okay, so how are we going to do this? Well, let's go ahead and just copy our left line renderer, and we're going to have to do the exact same thing for both. We're going to say that one dot set position. Okay, and it wants us to plug in two things. You can see it's got some arguments in here, and if we put a comma in there, it's going to move over to the next one, and it'll update our description down here, which is great. So for the first one, it wants an index, meaning there are multiple positions that we can make our line renderer connect to. We could have dozens and dozens if we wanted to, okay? The index is just the number in the order sequence, okay? But it actually starts with 0. It doesn't start with 1, which is a little bit confusing, and it takes a little while to get used to, but that is how code works. Whenever you're dealing with an array of stuff or a list of stuff, it starts at 0, not at 1. So we want to set the first position, which is 0, to be equal to what, right? Remember I said that this variable here, we cannot access it in this method over here because this is a local variable. Well, I'm not able to access it over here. So here's a really cool thing. You can create a method without actually knowing what you want to pass in yet. And we can do that by putting in arguments, okay? So what we're actually gonna do for the first time is put something in these brackets here. I'm gonna put in a vector2, and I'm gonna call it position. You can call it whatever you want. I'm calling it position. So what are we going to pass in as index 0? We're going to put in the position. So that's so confusing, I know, because it's like, this doesn't mean anything. We just put in a vector2 position here. But what we're going to do now, you'll notice, this is giving us an error. All those red squiggly lines, that means we have an error. So that means this is now not going to work. If I save this and go into Unity, it's going to give us an error because you have to fix any compiling errors in your code before your game can run. So now we actually have to put in a vector2 into the setLines method. So what are we going to put in? Our tuts position, right? The one that we just created. Okay, now we're passing in this variable into this method that is down here, right? So now this position is going to equal to that because we're passing it in here. I hope that makes sense. Okay, so that's position 1 of the line. It's going to be following the mouse wherever it goes, right? This set lines is being called in draw slingshot, which is being called whenever we're holding down the left mouse button in update. Remember, update runs every single frame of the game, right? This is going to run over and over and over and over again. So it's constantly going to be updating where our mouse position is and drawing the line to that. So that's index 1. What do we want the next index to be? We want it to be in an idle position that's connected to the slingshot, right? So there's actually some more variables that we need to set up here. So I'm going to go up here and I'm going to say private, and this time we want to plug in a transform variable, okay? Well, I always put in the type. You have to know what type of variable it's going to be before you actually create it. So it's what level of access, what type of variable is it, and then what is the name of the variable. That's always the order that you go in. So we're setting up a transform, and we're just going to call it the left start position. Okay. Going to do it again for the right start position. So now down here, for the other index in the left line renderer, we're going to set the position of now index 1, and we're going to set that one to the left start position. Sorry, that's giving me an error because this is a transform. So by creating a transform variable, I'm literally referencing a transform component on something. So now I need to actually tell it, well, I want the position of that transform, right? So we're going to say left start position dot position. There we go. So we're going to do the same thing with the right side. I'm going to do index 0 at position as well. Same thing. Okay, so we're almost ready, but we do have a problem, okay? Because if you really think about it, it does make sense because we are referencing just a line renderer, left line renderer, and another left line renderer, right line renderer. But how exactly is the compiler and Unity supposed to know which line renderers we're talking about? We could have hundreds of line renderers in our project, and we're not pointing these to anything. We're not assigning them to anything anywhere. So I want to show you one of the most common and one of the most popular methods of assigning a value to your variable. You're going to be doing this all the time. Okay. So I'm going to add a space before my private here, and I'm going to do a square bracket and say serialize field. Okay, and I'm going to do that actually for all 4 of these variables. You'll see what this does in just a second. It's so cool. Okay, so we got serialized field on all 4 of those. Let's go back to our project and see what that does. Boom. Okay, it now updated our script in our slingshot here with some blank fields that we can now drag stuff into. Okay, so now we can say, what is our left line render? It is this one here. What is our right line render? It's this one here. We can literally just drag and drop assign them that way. Okay, so what is our left start position and our right start position? Well, we're going to have to create those. So under slingshot, I'm going to create another empty and call this transforms. Okay, so I'm going to create a strip start left and a strip start right. It's actually another one I'm going to want to create for a little bit later called center position. Or center POS is fine. And idle position as well, or idle POS. So let's literally just position these where we want them to be. So our starting one on the left, I want it to start maybe right about there. On the right side, it's going to start right around there. Our center, kind of the position between the two, is right about there. And our idle, when later on, when we're going to have just a bird sitting in the slingshot, where do we kind of want it to be before we've actually clicked on anything? Maybe right around there, something like that. We can always tweak it later. So now back up here in our slingshot, we can say what's our left starting position. It's this one, and right is this one. So let's test that. Okay, so it's drawing some lines, but something isn't working quite right. Okay, so I'm looking at my code now and I used the wrong function. We're looking at when this was pressed this frame. That is not what we want. What we want is, we want is pressed, okay? We want to know, are we holding the mouse button down? Not did we just press it this one time, this frame, right? So is it being pressed down? Let's try that now. That's looking a lot better. Okay, so that is dragging around nicely, and if I let go, it stops following. And if I drag it, then yeah, I'm liking that. That looks pretty good. I might want to push this to the left just a bit more. Same with this guy. It might actually look better if we do darken this up just a tad. Let's try that. I got that backwards. Let's flip that around. So I want it darker at the end and a little bit lighter at the start. And I'll actually just copy that and paste it on this one. Okay, fantastic. Now we obviously do not, one of our problems is we don't want to be able to drag it this far, right? That's obviously a problem. I can't, I gotta drag this over just a little more. There we go. So we don't just want to be able to drag this around indefinitely, right? We would like it to have some sort of max distance on it. And by the way, you can tell, right, this line on the right side here, it goes behind the left side of the slingshot, which I really, really like. And that's happening because of the sorting layer, everything that we already set up. So that can just take a little bit of playing around, a little bit of tweaking with stuff, but I'm liking the way that this looks. And when we go this way, which we wouldn't want to shoot this way, but it's looking like the elastics are in the right order. So I'm happy with this layering. So I want to create a new just private vector2. We don't need to serialize it or anything like that. I just want to create one up here so that I can reference it multiple times throughout the script. So I'm going to set up a private vector2, and I'm going to call it slingshot lines position. Okay. so what I want to do is we are going to set that in here. We are going to make it equal to, that's how we can set it to something. We are going to make it equal to a vector3 dot clamp magnitude. This is a method that we can use to literally clamp our vector3 so that it does not go beyond a certain threshold. That will allow us to do exactly what we're looking for here, which is to not let it go beyond a certain distance. So what is our vector3 that we want to pass in? It's just our touch position, right? And then what is our max length? We're going to need to set something. So let's create another serialized field up here. So we'll create, and this time we're going to set up a float. What the heck is a float? A float is going to be a number that allows you to have decimal places. There are two numbers you're going to use the most as variable types in Unity. You're going to use integers or ints, okay, int, or floats. Integers are just whole numbers with no decimal places, and floats are numbers that allow you to have decimals, okay? So we're going to call this max distance. I'm going to set that to something arbitrary like 3.5 for now. We'll tweak that as we go. But now we can plug in that max distance here. But that is not going to be enough. What we're also going to need to do here is we are going to need to subtract the center position. I have not set up a variable for that yet, so let's go ahead and do that right now. I'm going to want serialized field private transform. Center position, and I remember we set up an idle. Let's go ahead and create one for that now as well. Okay, we're going to need to subtract the center position from our touch position. Okay, and again, that needs to be dot position. When you subtract one vector3 from another in Unity or in any code, what you are actually doing is returning a direction. One vector3 minus another vector3, that's going to equal a direction that points in one particular direction. I hope what I'm doing with my fingers there makes sense. That's not a code thing. That's a vector math thing. That's just something that it's really hard to wrap your head around, but that's just what it is. The actual formula for calculating a direction is your destination minus your origin, and then you normalize that vector. And we will be dealing with that exact formula really, really soon. So I will show you a better example of that coming up. So for right now, all I'm trying to say is, if this doesn't make a whole lot of sense to you, don't worry about it right now. It's the kind of thing where you need to play around with vector3s a little bit in order to make it make sense for you. So the last thing that we need to do is we also need to add the center position back in. Okay, so we're going to take the center position, dot position, and add this clamped direction with its max distance. Okay, so we're taking the center position, which is the vector3 that is between the two slingshot prongs. Okay, and then we're adding a clamped direction on top of that, which is not allowed to go any further, right? So if you picture it like that, it actually makes a lot of sense. Okay, so now down here, instead of passing in touch position in our set lines, we now want to pass in this new slingshot lines position instead. So let's go ahead and try that. And I will go ahead and show you what happens if you forget to assign any references here, but we didn't assign our center. So if we hit play and we click, it's going to give you this unassigned reference exception down here. Okay, sometimes it's very, very specific in terms of the error message that it gives you. This one, the variable center position has not been assigned. That one's really, really obvious, right? So let's go ahead and assign center position. And even though we're not using it in code anywhere yet, let's go ahead and assign idle as well, because we will want to be using that very soon. So let's try this now. Okay, much better, much better. So we're not able to go any further than that, which I really like. I think that's fantastic. Okay, so let's solve the next issue with this, because our problem right now is we can click literally anywhere on the screen. We can start clicking over here, and that just, something about that doesn't feel right. We should need to click at least around the slingshot and have kind of a radius area that we need to click in order to actually activate the slingshot elastics. Okay, so let's focus on setting that up next. So what we're going to do is actually create another empty under slingshot, and I'm going to call this colliders. Colliders are another type of component, and they are part of the physics engine with Unity. Colliders are very useful because they return a lot of information about what hits them, and in this case we can even do it with a mouse click. But they are also used for physics in terms of not letting your player go through walls and things like that. Every video game everywhere has colliders all over it. They are super, super useful. Okay, so in here in colliders, I'm actually just going to create a circle collider 2D. I'd like to actually see that, and to see it we can click on this little gizmo right here. And it is a little bit hard to see because of the sky. So I'm actually just going to go to the sky and click this little eye icon here just to hide that temporarily, which will make it a little bit easier to see here. So that is our circle collider down there. I would actually like to move it around and resize it so that it's just kind of around the slingshot. And you can adjust this to be however large or small you want. But basically we're going to make it work so that you will not move the slingshot unless you click within this area. So make sure that it's big enough. I think something like this should probably be pretty good. Now, as it stands, this is just a collider. So if we put any kind of physics object into this game, it is going to literally collide with this circle as if there's a wall there and bounce off of it. We don't want that. So what we can do is check is trigger. So now this is not an actual collider that things are going to collide with. It's now going to act as a trigger that we can then check to see, has anything entered this trigger? Okay, so we are actually going to set up another script because we want to put a script on top of this collider game object here. So back in your project window over here, right click and go to create and go to C# script. And we're going to call this one slingshot area. So let it do its thing, and then we'll attach it to our colliders game object here, and let's double click that to open it. I'm going to delete all that boilerplate code there. So we're going to create a method in order to detect whether or not our mouse is within that collider. Okay, so we're going to go ahead and we need to make this a public method because we are going to be calling it from our slingshot handler script. That's why we need to make it public. We need it accessible from other scripts. So it's going to be a public void. Actually, let's make this just so I can show you, and I hope this doesn't confuse you, but not all methods have to be voids. Remember I said that they can have a return type? Let's give this a bool return type, okay? And a bool, by the way, is a true or false statement. It's either it's going to be true or false, literally. So they are great for if statements to check whether certain things are true or false. So this is going to be a public bool is within slingshot area. So actually, just like our last script, we are going to need to return the world position of our mouse cursor. So let's create a vector2 and I'll call it world position. And that's going to be equal to our camera dot main dot screen to world point, and I'm going to need to add the using Unity engine dot input system in order to reference the mouse, or it literally won't let us if we don't put that up there. So now we can say mouse dot current dot position dot read value. Okay, so again, all this is we are creating a local vector2 variable called world position, and we're assigning our mouse's position on the screen and turning it into a world point using this screen to world point function. So now what we actually want to do is we're going to create an if statement. So we're going to say if. Now, there's a lot of built-in functions we can use here. I am going to use what is called the overlap point function from the physics system. So we are going to say physics2d dot overlap point. So what the overlap point function does is it literally checks one vector2, which is just an X and a Y position. So it's literally a point in your game. And it's going to check, is that point touching any colliders? Okay. So we're going to pass in our world position that we just found, which is our mouse position. Okay, and just like a function and just like a class, if you make an if statement, you do not put a semicolon at the end. What you end up doing is you do an open and close curly brackets so that you can run any code if that if statement is true, okay? Now we made this function a bool return type, which means if our physics is overlapping with the mouse's world position, meaning if our mouse is actually touching a collider in the world, then we want it to return true, right? And by the way, if you ever want to comment, just like write some text that doesn't actually do anything, it's not actual code, just do 2 forward slashes and then you can type anything you want, like return true, apparently, that I just typed, right? So in this case, because this is not a void, this is a bool, it wants a return type. That is why this is giving us an error right now. So if this is true, we will say this bool method will return true. Otherwise, which is going to be else, okay? So that is another statement we can make. If else is very common. You'll see those all over the place. So we could say else return false. Okay? Now, the only problem with this will work right now, but that's because we only have one collider in our game. If we were to introduce any other colliders, this will return true no matter what collider it's touching, okay? It doesn't matter what collider. So what we actually need to do is we can add a comma over here, and there is a second argument we can enter called a layer mask, okay? So that is how we are going to control this. We want to create a layer mask variable that is only going to signify our slingshot area. So just like all variables, we're going to put them at the top of the script, and we are going to say this is a private layer mask, and we'll call it slingshot area mask. Okay, and in order to set this in the inspector, we're going to serialize this field as well. So now we can plug in that layer mask right here. Okay, so let's go back to the inspector for a second. You will notice, by the way, it even puts spaces in between your words here, and that is because we are following the standard naming convention with our variables, which is you start with, and it'll ignore underscores if you do that, but you start with a small letter for your first word, and then every new word afterwards, you start with a capital letter. Why we do it that way, I don't know. That is just how the coding convention works, and Unity knows that, so they look for that, so that is how they know to actually end up changing it to a more friendly text like this here. So anyways, we have our circle collider on top of this collider's game object under our slingshot. So what I actually want to do is assign an area mask to that slingshot area script, okay? So in order to do that, we need to create a new layer. So you'll see up here, we have something called layers, okay? And right now there's only 5, and I don't want to use any of these, so I want to add my own. So as soon as I click that, it's going to bring up this tags and layers and blah, blah, blah. We can create up to 32 because it starts at 0, so 31 is actually the 32nd one. That's the cap for layers, and I've never gone above that, but you do just want to keep that in mind. You can't go nuts with these, but I am going to set this one to slingshot area. Okay, so just that means I created one. That did not assign it over here. We need to go back to colliders, click on layer, and now make it slingshot area. And now let's assign that here, okay? So now it is only going to return, this if statement is only going to return true if we are touching, if our mouse position in the world is touching a collider that is on the slingshot area mask. And now this one it's on our slingshot area, okay? Now currently we set up this script and we attached it to our slingshot area and we created this method, but this is not being called anywhere. You can actually see that right here. There are 0 references. It's not being called anywhere. If a method is not being called anywhere, it's not doing anything. It's literally just sitting there. You know, it can be used, but it's not doing anything right now. If we click play right now, nothing is going to change. So how are we going to do this? Because right here, what we're doing is we're looking for, okay, is our mouse button pressed down? I always want to detect if on my very first click that it's within that mouse position. And then honestly, I want to be able to drag it around wherever we want on the screen. Okay, so we need to be smart about how we set this up. So I'm going to create now a bool variable. We're going to make it private. It's going to be a bool. And if you forget, a bool is either a true or a false. And I'm going to call this one clicked within area. Okay, and bools, if you do not specify what they are at the beginning, they're just going to default to be false. Okay, that's just how it is. You could set it up here and say, oh, it's equal to true, right? If that's what you wanted it to start as, but we don't want that. We want it to start as false, and we will set this to true if we click within the area. Okay, so this right here is actually fine. What we are going to do instead, and again, don't forget that the update runs every single frame of our game. So this is always called by itself. So we want to say if our mouse.current.left button.was pressed this frame, we did want that in there. Then we want to say if it was clicked this frame and it was within the slingshot area, then we are going to set this to true. Okay. So how do we call this method here from this script? I can't just call the method. These two scripts do not know about each other. I could attach slingshot area. I could attach that script to hundreds of game objects in my game if I wanted to. There's no limit to how many game objects you can put one script on top of. So again, I can't just call this. It needs to know exactly what script I'm talking about. So now what you're going to see is we can actually create a variable of this script right here. So I'm going to say serialized field private slingshot area, and we'll call it slingshot area. So now you remember serialized field, we're going to have to remember to assign that in the inspector. But now we can go over here and say, okay, did we press the mouse button down this frame? How do you say and in an if statement? What you're going to do is, whoops, sorry, two of those symbols. If you put two of those back to back, then that is going to mean and. Quick lesson right now. If you want to do an or, because there is or as well, that's going to be two of those symbols. That is, in case you're not sure, that is actually two buttons above your right side shift on your keyboard. I actually do not know what this is called, I'm ashamed to say. And you can also want to check to see if something equals something. So if you wanted to do that, you would put two equals signs, not one. So you could say, does that equal something? Okay. So there's a lot of different things that you can do in if statements. But in this particular scenario, we want to say, was our mouse button pressed this frame? And now we want to do, whoops, our slingshot area dot is within slingshot area. Okay. And whenever we call a function, we have to do the open and close bracket. That's why that is there, because this is a function that we created, right? So this is a bool, which means it's literally returning true or false. So now this if statement is saying, okay, we are only going to run this code here if this is true and this is true. Okay. And if that is in fact the case, then we are going to say clicked within area is equal to true. Now, how does that actually help us? Because this, again, all we're doing is assigning a bool. This actually isn't helping us. Well, all we want to do now is make sure, okay, we want to only draw the slingshot if we clicked within an area. So we're just going to add another and to our second if statement and say and clicked within area. This is actually a short form, by the way. You could say clicked within area is equal to true. Okay, that is exactly the same thing, but you don't need to do that. You can literally bypass the is equal to true and just say and clicked within area, right? And the short form, you could do the same thing. If you wanted this to be false, you could say is equal to false, or a shortcut for that would be put an exclamation mark at the beginning of the variable. That means and clicked within area is equal to false. Those are just two little shortcuts that are very, very useful, because you're not going to see a whole lot of this in code because nobody does that when you don't actually need to type it. So just get used to seeing it this way. So now we set this to true here, okay? And then we check, is that true here? Now, the only thing is we need to be able to set this back to false again. So you might have already seen where this is going, but now we want to check, okay, if our mouse.current.left button was released this frame, okay? If we released our left mouse button, then we are going to set clicked within area back to false, okay? And that's just so that it is reset and we can run this code and all of the logic will flow all over again. So everything in game development is about testing. So I think this should be good. Let's go ahead and check it and find out. So we should have it so that if I click like over here, oh, yep. So we're getting an error and it's because I forgot to assign some references. We just set up this slingshot area and it's saying, where the heck is that? It's attached to our collider's game object. Okay. So you can literally just drag in whatever game object your reference sits on top of in there and it'll just know to grab the correct one. Okay. So let's test that out. So if I click over here, that is doing absolutely nothing, which is what we want. That's great. Now, if I click over here, perfect. It is working. And if I let go, that's going to stop. If I click over here, that's not doing anything. But if I go back here, it's going to follow it again. Perfect. That is working exactly like we wanted. Now, you could see the more variables we start to add, this can start to get messy really, really fast. So I'm just going to show you a little tip to help us keep this a little bit more clean. And that is just with a little thing called an attribute. I'm going to put an open square bracket and I'm going to type in header. Okay. We're going to tab, open our brackets, and then we can type in what we want that header to be called. So here, I'm going to put line renderers. Okay. Here, I'm going to do the same thing and put transform references. Let's say this one can be scripts. And slingshot stats, maybe. So that's just going to add some headers that's bolded and add a little bit of space after each one. That's just going to help us to keep things tidy and keep it more readable. It really is worth taking the time to keep your stuff readable because this starts to get overwhelming very, very quickly if you let it get messy. One thing that I actually almost completely missed it though, but if we're playing, our line is actually just sitting right there, which we definitely don't want, right? You can see because it disappears as soon as we go over here. I don't want those just sitting there when we start the game. So let's fix that before we move on. So let's go back in here. All right, so how can we do that? Well, if you remember from the very start of this, we said there is a built-in Unity method called the start function. There's another one called the awake function. Start and awake are literally almost exactly the same, except awake is called first. Awake is the very, very, very first thing that gets called when you click play on your game. So that is a method you are going to be using a lot to just initialize some stuff. So what we actually want to do is make these line renderers inactive at the start of our game. And then when we actually click within the area, I would like to enable them. Maybe we can enable them in the draw slingshot method. So in our awake, let's go ahead and say left line renderer dot enabled is equal to false. And we'll say the same thing for the right one. And in draw slingshot, we will say if left line renderer dot enabled. Actually, what we want to say is if it's disabled, and same with the right one, right? We're going to put an exclamation mark at the beginning to say this is false, meaning it is false that the left line renderer is enabled, and it is false that the right line renderer is enabled. If that is the case, then we are going to enable them. And the reason I'm putting this within an if statement is so that it only just runs the one time. So let's try that. So it won't change it within our game view yet until we actually hit play, but that is the part that actually matters. So we hit play, there we go. There's nothing there, but if I click over here, then they actually draw, which is exactly what I want. Awesome. So let's add the Angry Bird to our game now. So I'm going to start, by dragging in our sprite. So let me find him. Yes, he's in here. He's one of these. There he is. Boop. I'm going to call him Angie Bird. And just like everything else, I'm going to scale him up to 2. Okay, and I actually want his order in layer to be 11. Okay, so now we need to get into a little bit of the built-in physics in Unity. And this is actually really easy and it's a lot of fun because right now, you know, I dragged in a sprite. If I hit play, he's literally just sitting there. I can't click on him. I can't make him do anything because he's just a sprite. So we're going to need to add some physics to him. How we do that is by adding what's called a rigid body component. And you'll notice for a lot of the physics stuff, there is a regular version and a 2D version. The regular is for 3D games. The 2D is for 2D games. So we want the rigid body 2D. Okay, so this is what's going to give him gravity. We can give him a mass. We can do all sorts of things. Okay, I'm going to go ahead and get rid of any angular drag that he might have. So right away, let's just click play and see what happens here. Okay, he falls, which is so cool. So that already is applying physics to him. It's applying gravity to him. Okay, all of those calculations are being done for us, but we don't want him falling through the floor, okay? We want him to actually hit the floor and stay there. So how do we do that? Well, he is going to need a collider on him, okay? So we are going to add a circle collider, 2D. And again, to see it, we can click on that little edit collider there. I think I'd like it to be centered more around his body than on his feathers. So I'll do something like this. That looks pretty good. Okay, we are not going to make this a trigger because we literally want this to be a collider. Okay, so if we hit play, he's still falling through the ground. Why? That is because our ground, just like our bird was a second ago, it's just a sprite. Our ground is nothing. So how is it supposed to know that we want it to stop right here? So right now, our grass needs, and not a circle, obviously, we're going to add a box collider 2D to it. And let's see that here. If we click on that, oh, that's not what I want at all. It's just this tiny little area here. I want it to cover the entire ground, which is massive, by the way. And I just realized I put that on my grass, not on my ground. So I'm just going to go ahead and correct that. Whoops. Okay, but same thing applies, right? That's just this little area over here. What's cool though, is because we set this to tiled, we've actually got a little option here that we can select auto tiling. Okay, if we click that, we are no longer able to edit the collider because it literally will fit for us based on how we tiled it. Okay, so even if I end up resizing the width of this, it's going to automatically resize the collider, which is so cool. Okay, so now let's hit play and see what happens. Okay, there we go. So he's actually staying on the ground now. So the two colliders are interacting with each other. The physics is making him go down, and then the collider is making him stop. So that is so cool. So we are, of course, going to be using physics in order to fling him off of the slingshot. So in order to make all of that happen, we are going to create, you guessed it, another script, and we're going to put it on top of our Angry Bird. So we're going to create a new C# script, and I'm going to call it Angry Bird. And let's add that on top of our Angry Bird, and let's open that up. And again, I always just get rid of this boilerplate stuff here. And I feel like it's worth mentioning because you might be curious as to why we are creating so many different scripts to handle all of these different things. Why are we creating multiple scripts and attaching them to different things in our game? The reason we're doing this is because we are trying to follow the single responsibility principle, which is a coding principle that is there to really just ensure that you are following good coding practices so that you can build modular games that you can end up expanding upon more easily. If we were to do everything in one single script on one game object, the bigger our game gets, the more impossible that's going to become to maintain. So a good habit that you want to get into in game development is that every single script has one responsibility. So our slingshot handler, that is handling all things related to our slingshot. Our slingshot area, that's dealing with clicking in literally our slingshot area. And our Angry Bird script, that's going to deal with all things related to our Angry Bird. So we're going to actually create his launch function here, which is going to deal with the physics and actually launch him off of the slingshot. We could do that from the slingshot handler script, but that would not be following the single principal responsibility. So it's a bit of a mindset adjustment, but it's a good habit that you want to make from the beginning. So we said our purpose for this script was to create a launch function. So let's go ahead and do that now. So I'm going to set up a public because we're going to be calling this function from the slingshot handler, but the actual code for it is going to be contained in the Angry Bird script. So a public void launch bird. So what do we actually need to launch the bird? So remember, our rigid body here is what allowed us to add gravity to him. So the rigid body is what we are also going to reference in order to apply some forces to our bird. All things related to movement with the physics system, we're wanting a reference to the rigid body component. So what we're going to need is to set up a rigid body variable. Now, so far, what you've been seeing is serialized field, and then we drag and drop it in through the inspector. I want to show you a different way that is also very, very common to get a reference to certain components. So we're going to set this up as a private. We're making it a rigid body 2D. I'm just going to call that RB. Okay, now remember, our awake function gets called as soon as we hit the play button on our game. So if we want to initialize stuff, or if we want to assign a reference to one of our variables, that is a great place to do it. So what we are going to do is say our rigid body is equal to, and you'll see it's already trying to autofill here for me. It knows exactly what I want to do. We're going to do get component of type rigid body 2D. And you'll see that's within these less than and greater than signs, whatever the heck they're called. And you'll see that a lot when you're dealing with generics, and that's definitely a more intermediate topic, so you don't need to know about that. It's just you'll see that when you can literally pass in any kind of variable type. We can use get component, we could do transform, we could do literally any kind of component, including other scripts that we've written. So what get component actually does is it is going to look on the game object that our script is on. Okay, so we've got Angry Bird on top of our Angry Bird game object. So it's going to literally go through all of the components and try to find a rigid body 2D component. And if it does find one, then it's going to assign it to our variable. So now this variable here, it knows that we're talking about this rigid body 2D, specifically this one in the game. Because again, we could have hundreds of game objects and hundreds of rigid body 2Ds. So you always have to assign what variable is pointing to what. And get component is another really, really common way of doing that from your wake function, or you could also do it from your start function as well. That's totally fine. Okay, now here's the thing. Right now, whenever we press play, he falls, right? And actually what we're going to want to have happen is we want him to be in the idle position over here, and we definitely don't want him falling, okay? So what we actually want to do is at the start of the game, we want the rigid body's type to not be dynamic. We want it to be kinematic. If it is set to kinematic, then he is not going to fall. Gravity will not be applied to him. What we will do with our code is set the body type to dynamic at the right time when we actually release the slingshot. So what we first want to do is over here in awake, we are going to say rigid body.isKinematic is equal to true. Now, another thing that could cause us problems is, again, we've got a collider on our Angry Bird right at the start of the game. Depending on how we end up building our level, that could end up giving us problems. We don't necessarily want him to have a working collider until we have released him from the slingshot. So what we're going to do is we're going to grab a variable, and we're going to assign the circle collider 2D component to it, and then we are going to disable that. So just like with the rigid body, we're going to set up a private circle collider 2D. We'll call it circle collider. Okay, and we can do the exact same thing. We can do get component just like we did with the rigid body. So that is equal to get component circle collider 2D, open and close bracket, semicolon. Okay, so now it knows what circle collider we are referencing. So again, now after we have to put these lines of code, right? We're going to be changing. Let's do this first. So we're doing circle collider. Oops. dot enabled is equal to false. Okay, so we have to do these lines of code after these ones. Otherwise, it's, again, not going to know which rigid body or which circle collider we are talking about. We have to get the components first, and then we have to do these lines of code. So the order does matter. So what some people will do for that scenario is, okay, they would say, let's do our get components in the awake function, and then let's actually change those components in the start function. That is completely optional, but it is a nice way to separate out the logic and make it a little bit more clear, but it doesn't matter. It'll work either way. If we go to Google and we type in Unity order of execution, and we actually open that up, it'll actually give you a graph here of the order that everything is actually rendered in. And this is like super confusing to look at, but you will see here awake is the very first thing. There's another one called onEnable that I didn't tell you about. And then there's the start function, right? So we definitely know based on this graph that awake is called and then start is called. So for our launch force function, there are two things we're going to need to know, but we don't know what they are yet. So remember before we ended up entering something into our parentheses here, we're going to do that again. The two things that we want to know is what direction is the force we want to push him in, and then what is the actual force multiplier that we want to apply to that so that we have a little bit of control over how fast he shoots out. So a direction in a 2D game is always going to be a vector2. So we're just going to set up an argument vector2 type called direction. And for our force, that's just going to be a floating point number. So we'll say float force. Okay, so that's going to force us to pass in a vector2 and a float whenever we call this function. Otherwise, we won't be able to call it. So, okay, we made it is kinematic at the start, and we disabled our circle collider at the beginning. Now, when we launch him, we actually want to reverse those operations. Okay, so we're going to say rb.isKinematic is equal to false, which is automatically going to change it to dynamic, which is going to turn gravity back on. Then we're going to enable our circle collider so that he can collide with our piggies and our boxes and our ground and all that good stuff. Then we are going to actually apply the force. So the way that we're going to do that is we're going to reference our rigid body and say dot add force. Okay, so it wants a vector2 and it named itself force. So our force, what we are going to pass in is our direction multiplied by our force. Okay, and we can actually pass in a second optional argument here, which is the force mode 2D mode. So there are two different modes. If you don't select one, it's going to pick force by default. That just means there's going to be acceleration first. What we actually want is impulse, meaning we want him to be at the maximum speed straight away. So our direction multiplied by our force, we don't want to accelerate to get there. We just want it to instantly at the snap of a finger be at that speed. So that's the difference between those two. Okay, so we're choosing force mode 2D dot impulse. Perfect. Okay, so let's go back to our inspector for just a second. Now, currently we have a bird that's just floating in the air, and I don't want him to start there. And the other thing is that we need to solve is I actually want to be able to spawn in multiple copies of this angry bird, but right now we only have this one guy sitting here, right? We don't really have a good way of being able to copy him into the project. So what we are going to do is turn him into what's called a prefab, which literally stands for a prefabricated asset. So I'm going to set up a new folder for that and call it prefab. And what's really cool is literally you can just drag and drop our Angry Bird right in there, and it's going to turn him into this nice blue icon here. If you see a blue icon anywhere in your project, that means it is a prefab. So what the heck is a prefab? Well, what we have done is we turned just a game object in our hierarchy with all of these different components on him, and we turned him into an actual asset that is now stored in our project. I can actually delete him out of our hierarchy, but he's still here saved in our prefabs folder. He is saved with his rigid body, with his circle collider, and with his script. And if we had any serialized field properties on there, all of those and those numbers would be saved as well. So now that we've saved him into an actual asset, we can now spawn him into our game world whenever we want. So how we would do that is let's go back to our slingshot handler script, and we're going to need to set up a variable for that. So I'm going to create a new header here. Whoops. I'm going to call this bird. We're going to do a serialized field, and you know, we're going to do private. And this is going to be of type GameObject, okay? So we want to spawn in Angry Bird object. Actually, I'm going to call that Angry Bird prefab. Okay, so go back to your inspector for just a second because I want to not forget about that and actually assign it straight away. So we haven't done anything with that variable yet, but now we have this empty field right here, and we can drag and drop our Angry Bird prefab in there, okay? Now, this game object is pointing to a certain prefab. So right now, at the start of our game, the Angry Bird is not actually in the game. So what we want to do is spawn him in. So let's create a method for that. And this is actually starting to get a little bit messy here. It's getting a little bit long. So what I am going to do is after our update method here, I'm going to type in hashtag region, and I'm going to call these methods, because this is the draw slingshot and the set lines method below that. I'm going to call this slingshot methods. Okay, and at the end here, before this last curly bracket, because that's the end of the class, we don't want to go past that. We're going to do hashtag end region. Okay. Literally all that does is it's a nice little kind of container that we can now minimize right here so that we don't need to look at all that code if we don't want to. Okay, so I'm going to set up another region called Angry Bird methods and end that region. And now in here, this probably only needs to be private. Again, we can change it later if we need to. It's going to be a void spawn Angry Bird. So where are we going to call the spawn Angry Bird? It doesn't do anything yet, but we might as well go ahead and call it. We're going to do that in the awake function. Okay, so now as soon as we play the game, spawn Angry Bird is going to get called. And in here, we're going to put in the code that actually spawns him into the game world. So there's actually two things we want to do here. One is going to be, we want to set the slingshot elastic positions to actually be in the idle position, and then also spawn the Angry Bird onto the idle position. So remember up here, we set up this idle position transform. We're finally going to use that. So we can actually just call our set lines method that we already created, but we're going to pass in the idle position dot position. Okay, so that is going to call this method right here. It's passing in position, which is going to draw right from our starting position all the way over to our idle position. So that's perfect. We just want to do it once. And now we want to actually spawn the Angry Bird in. So we're going to do that with a method called instantiate. Instantiate is literally spawning stuff in. What you are going to do is create a copy of your prefab asset and spawn it into the game world. So our first argument is what game object, right? It's called object original. What game object do we want to pass in? We want to pass in our Angry Bird prefab. We also want to tell it where we want to spawn. So instantiate, you can see we actually could leave it here, but it's not going to know where to spawn it. So if we were to leave it like this, let's actually go ahead and just see what that does. So that literally just spawns him right in the center of the world, which is not what we want. So we want to be able to tell it where he is going to be passed in. So our transform is going to be the idle position dot position. Now next, if we give it a transform position, we also have to pass in a rotation as well. The variable type is not rotation. It is something weird called a quaternion. So those are really, really complex, and even a lot of intermediate coding users don't understand them all that well. So all that you need to know is we want to spawn him in with no rotation. Okay, we can always change the rotation later on, but we're just going to spawn him in with no rotation, which means he's going to be facing the exact same way as the asset copy. Okay, so we're going to say quaternion.identity. What the heck does that mean? That's just a short form way of saying 0 rotation. Don't ask me why, I don't know. Okay, let's see what that did. Okay, it actually spawned the Angry Bird, but for some reason the line renderers are not updating. Why not? Well, if we look inside of our slingshot handler, let's open up our slingshot methods. Right here, we are not enabling our line renderers until the draw slingshot method is called, which is only called when we press the left mouse button down. So we might actually want to move this into the set lines method instead, so that no matter where we call the set lines method from, they're going to activate. That probably makes more sense. So let's save that and give that a try now. Okay, there we go. So he's actually spawning in our idle position, and the slingshot lines are updating as well. That is fantastic. And I'll just play it again on maximize. But now here's the thing. You'll see the Angry Bird does not follow along with the slingshot when we're clicking and dragging around, and that's no good. So let's fix that next. So we're going to go back into our slingshot handler, and we are going to set up a private void called position and rotate Angry Bird. So you're probably already guessing we're going to end up rotating him in here as well, but let's just handle position first. Okay, now here's the thing. I want to be able to reference a game object and grab the transform component of that so that I can then manipulate the position and then tell it to go to a certain position, right? But I don't have a game object to point to. Yes, we do have this one up here that we spawned in, but that is pointing to the prefab. Once we call this instantiate method, it is no longer just the prefab that it's referencing. It is now literally creating a copy. Let me actually show you. You will see if I play focus that it's called Angry Bird clone, okay? You will always see the word clone after we use the instantiate function. So this reference here, you can see we can actually click on it. It's highlighting this prefab here. It is not pointing to this clone. I could call instantiate over and over and over and over, and we could have many, many, many clones of our Angry Bird, right? So this reference here is not what we want. So we cannot grab the transform and position of this because that's not pointing to any specific game object in our game. So what we are going to do is back in our slingshot handler, we are going to set up a private game object. We're going to call this spawned Angry Bird. Okay, so nothing is pointing to this. Nothing has been assigned to this yet. What we are going to do is actually go down here and say our spawned Angry Bird is equal to instantiate blah, 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 blah. Okay, the instantiate method's really nice. It allows us to have a return type on it of type game object. Just like in our slingshot area where we had a return type of bool, you can set up methods of any return type, right? You can say private game object, blah, blah, right? And you can set up a method that way and return a game object. That is what instantiate does, but it's optional. You don't have to utilize that. But in this particular scenario, we really want that. So now we have our spawned Angry Bird is being assigned to this variable every single time we spawn in an Angry Bird. So now we can actually use that and say its transform.position is going to be equal to something, okay? So what is that going to be equal to? Let's open up our slingshot methods again. Remember over here, this is where we actually set the position of the lines, right? We're passing in slingshot lines position into the set lines method here. And this variable here is actually one up here that we created. So it is being stored. We can use it in as many methods as we want. So we can actually set it to the slingshot lines position. Okay, now we just need to call this from somewhere. So actually we're going to go up into our update method and we're going to call that right after our draw slingshot method. While our mouse is being pressed down and we've clicked within the area, we're going to draw the slingshot and we're going to move the bird. And that's happening every single frame because it's in the update method. Let's test that. Oh, I changed a bunch of code while I was still in play mode, so you'll often get errors when you end up doing that. So just click off of play mode, clear your errors, and everything's fine. So I'm going to go to maximized. Okay, awesome. So he is keeping up with our slingshot. This is fantastic. Now, one thing that's bothering me is the elastic is going into the center of his body. I would really like to offset that so that it's at the back. So we're going to go back into our slingshot handler script to fix that. Okay, so I told you earlier that we were going to do a proper direction calculation. Now we are actually going to do it. So there's actually two different variables we are going to set up here. We're going to set up, and they're both going to be vector2. So we're going to set up a private vector2. The first one is going to be called direction. And the other one, we're going to call it direction normalized. And I'll explain the difference in a little bit. So we need these direction vector2s, which is literally an X and a Y position. Again, a direction, it's just think of it as it's something that's literally just pointing in a certain direction. The best way I can think of to explain a direction is if you think of a controller, right? All it takes on the analog stick is an X position and a Y position. If I press this all the way up, and it's perfectly centered, then the Y is going to be a value of 1 while the X is a value of 0, right? That is an up-facing direction, right? And if I point it all the way to the right, that's going to be an X value of 1 and a Y value of 0, et cetera, right? So all you need is an X and a Y position in order to have an actual direction. There's a hair in my eye. Okay, so we want this direction to always be updating based on where our mouse click is. So the direction is going to have to be updated somewhere in our update function. And I think the draw slingshot will be a really great method to update that in. So we're going to say in the draw slingshot method, our direction is equal to, what is it going to be equal to? Remember I said that the calculation for a direction is going to be the destination, meaning where you want to go, minus the origin, meaning where you are. So where you want to go minus where you are. Okay, so that's going to be, where do we want to go? We want to go to the center position, which we set to literally the position between the two prongs with the slingshot. So center position dot position minus our slingshot line's position. Okay, now that is going to give us an error right now, and it's going to tell us that minus is ambiguous on operands of type vector3 and vector2. So this slingshot lines position up here, that is a vector2. Okay, this is a transform dot position, right? Center position right up here. We've set that as a transform, and within each transform, you can always grab the position from that. That is a vector3. So what we are actually going to do is called casting. Okay. You can basically turn a vector3 into a vector2 because we don't care about the Z position. The Z would be depth in our game world, and this is a 2D game. We don't care about depth. So we are going to cast this vector3 to be a vector2 instead. So the way that we do that is just put it in brackets in front of the one that was a vector3. That's going to cast that and turn it into a vector2, which then fixed our error. Okay. I could have done the same thing by casting this to a vector3, not a vector3, right? So that would have worked too. My preference, just for whatever reason, my personal preference is to turn this into a vector2. It doesn't really matter though. Okay, now we set up two variables. We did direction and we did direction normalized. The only thing different is direction normalized is going to be equal to our direction dot normalized. Okay. All that means is the magnitude of the direction, it's not going to go above 1, which is just like the analog stick, right? The max value is going to be 1. Our direction based on this calculation could be anything on the X and Y. It could be a lot more than 1, right? Direction normalized is just going to ensure that it doesn't go beyond 1, which can be very, very useful for certain math operations. Okay, one more variable that we need to set up is going to be a float, and this is going to be an actual offset, and we're going to use it as a multiplier. So we're going to put this under bird. So we are going to serialize this so that we can change it in the inspector on the fly really easily if we want to. So private float, and we're going to call this Angry Bird position offset. Okay, and that's going to be equal to 2f. I don't even remember if I explained with max distance before. I think I just breezed over it. If you are setting up a float, you have to put an f after the number, okay? Just for whatever reason, that's what the compiler likes. That just lets it know that it is a float. If we were to set up an int, then you would not need to do that. But for whatever reason with floats, you have to put an f after the fact. It's just something you got to get used to. Okay, so this is an arbitrary number. We might end up changing that in the inspector in a little bit, But what we are going to do is go back down here to our spawn Angry Bird method. So we need to change the bird's position in two places. We need to do it in spawn Angry Bird and position and rotate Angry Bird. Now we are going to need to calculate the direction again in spawn Angry Bird, even though we did it over here in draw slingshot. And the only reason for that is because this does not run until we are pressing the mouse button, but spawn Angry Bird is called in awake, right? So if we try to reference this direction, it's not going to find anything because it hasn't been assigned anything yet at that point. So in spawn, what we're going to do is just set up a local variable. We don't need to go up here and set up another one. That's a waste. We only need to reference it once within this actual method. So we're going to set up a vector2 called direction. I'll just do dir, and that's going to be equal to our center position dot position minus our idle, which is where we set him to right here at the beginning, right? We set him there, and we actually spawned him in with that as well. So our direction is from the center to the idle position. And we want to say dot normalized. We want this direction to be normalized. Okay, so what we're actually going to do is just a little bit of simple vector math here. This second argument here, right? If you want to make it pop up again, just put in the comment, right? We're in our vector3 position part right here until we pass that comma. What we want to do is actually change this position just a little bit. So to make this a little bit neater, what I'm going to do is set up another vector2 and call this spawn position. Okay, so the spawn position is going to be equal to our idle position, and we're going to add the direction that we just calculated multiplied by our Angry Bird position offset. Okay, and it's going to want me to cast again. So that is a float, that's a vector2, so let's cast this as a vector2. Okay, to get rid of that error. So now, instead of plugging in the idle position dot position, we can plug in the spawn position that we just calculated. Okay, and we're going to do basically the same thing in position and rotate Angry Bird, except for this one, we happen to already have this normalized direction up here, and position and rotate Angry Bird is not called until after draw slingshot, right? So we know for a fact that this is already going to be set every single time. So for this one, we're good to just say his transform.position is going to be equal to his slingshot lines position plus the direction normalized multiplied by that offset again. Angry Bird position offset. Okay, so let's go check that out. Okay, so we can hit play. That doesn't look right. So maybe our offset is just too big. Let's crank that way down and see what kind of a difference that makes. That's looking a little better, okay? So it's still not quite where I would like it to be. So let's adjust it just a little bit more. Let's try 0.275. Okay, that is actually looking pretty good. It's following him about where I would want it to be. I wouldn't normally be putting him that way, so that's pretty good. I'm pretty happy with this here. Okay, one other thing that I would love to be able to handle is I would love to get the bird looking in the direction that he's facing. That would make it look a little bit nicer. So just like changing his position, there would be two places that we want to do that. We would want to do that when we spawn him in, and then when we are positioning and rotating the Angry Bird. So what we're going to say when we spawn him in, actually, is we're going to reference our spawned Angry Bird again, and just say his transform.right is going to be equal to that direction that we calculated. Okay, and let me show you something really quick. So if we press play, you can see he is facing in that direction as he should be. He's not going to update. He'll just stay in that position because I didn't change it in the other method. But I wanted to show you this in the scene view. If I bring in this Angry Bird here, by the way, if you ever want to just like hone in on anything in the scene view, right? You might be like zoomed out and be way over here. You can just click it and press the F button on your keyboard and it'll go right to it. Okay, so you'll notice if we click on the move tool here, we've got a green arrow that's pointing up, that's the y-axis, and we've got this red arrow pointing to the right, which is the x-axis. So we are saying we set his transform.right. What does that mean? You can think of the transform.right being his red arrow here. When we rotate him, by moving him around on the Z position, right? This is showing us global vectors. If I change this up here to show me what are the local vectors, meaning what is the actual rotation of just this object, not the entire scene, right? Global is showing us what is the up and what is the right of the entire scene. If I change this to local and click on the Angry Bird and I rotate him around, you can see that the red arrow, literally meaning his transform.right, is going to be pointing in different directions. Okay, so with this code here, we're literally saying which way do we want him to be pointing. We want him to be pointing in this direction. Okay, so I'm going to change that back to global because that's usually how I like it, and get rid of that rotation. Actually, we can just delete him right out because we spawn him in with our code now. Okay, so let's do the same thing in this method here. Let's go ahead and say that spawnedAngryBird.transform.right is going to be equal to our direction normalized. You notice we haven't used the unnormalized version of this vector yet. We will eventually. It was just easier to set them both up at the same time. Okay, let's check that out. Okay, now perfect. So he's rotating around and looking in the direction of the slingshot. I quite like that. Now, what we finally want to do is when we release the slingshot, we want him to fling forward. And this is going to be really easy because we already set up, right? We set up the Angry Bird script. We already created this launch bird function. All of the necessary setup is already there. So we're going to go back to our slingshot handler. And really all we need to do is grab a variable to this Angry Bird script, and then we can call it when we release the mouse button. Now this can be a little bit tricky. How do we get a reference to this Angry Bird script? We cannot just set up a serialized field and plug it in there. Why not? The reason we can't do that is because, again, this Angry Bird script is attached to a prefab that is sitting as an asset that we can spawn multiple copies of. So again, if we do that, it's not going to know which script we're grabbing. Now, we handled that a very similar problem with our game object, right? We set up this private game object called spawned Angry Bird. I'm going to show you a really neat little shortcut here, okay? I don't want this to be a game object. We are going to change this to an Angry Bird, and we're going to do the same thing here with this game object as well, okay? Okay, so let's go back to our inspector. You can now see that it changed from a game object here to the actual Angry Bird. It automatically updated everything. It kept the reference. That is fantastic. So now when we instantiate in, where is it? Right here, when we instantiate in this spawned Angry Bird, it is now no longer grabbing a reference to the game object. We don't necessarily need that. We need a reference to the Angry Bird here. So that solved our problem. We already have a reference to this Angry Bird script. So now all we need to do is say when our mouse was released, we're going to call spawned Angry Bird dot launch bird. What is the direction? We already calculated the direction, right? This time, we do not want to use the normalized direction. We want to use the regular direction because we want him to fly further based on how far back we pulled or how big the direction is. So we don't want to normalize this one. We don't want to put any arbitrary caps on it. So that is why we set up this one, because that will actually make it so that the further back you pull him, the farther forward he's going to go. So we're going to launch him by that direction. And did we set up a force? I don't remember. We did not. So let's set one up now. That's just going to be another float. We'll put it under slingshot stats. We'll serialize that so that we can change it on the fly very easily if we want to. So we'll set up a private float and we'll call it shot force. And let's try 5 to start with. Okay. So we'll plug in shot force here. All right, let's give that a try. Okay. A couple of things. I felt like that was a little bit weak. I think I'm going to bump that up to something more like 9 and try that again. There, I'm a little bit happier with that. Now, the other thing is you'll notice that he wasn't really the smoothest when he was moving. He was a little bit jerky, and I hope that my screen capture picked that up. But if, in case you didn't, it was a little bit jerky and it wasn't the best. So what are we going to do about that? By the way, if you want to change something on a prefab, I don't want to skip ahead here. What you want to do is double click on the Angry Bird. Okay, that's going to bring us into this whole different looking scene here. That's because we're within the prefab's context mode. So it's really just kind of isolating that prefab by himself. So now that we're in this mode, we want to change something on his rigid body. We want to turn on interpolate. We want to change that from none to interpolate. Okay, what that is going to do, I actually have a really cool way of showing you how this works. Okay, so let's turn this back to none just for a second so that I can show you exactly what it does so that you definitely understand. It's better that I show you than tell you. What I'm going to do is slow down just for testing, just so that you can see. I'm going to slow down time when we release the mouse button. Okay. So the way you can do that is say time.timescale is going to be equal to, I don't know, let's say like 5% of what it usually would be. Okay, so this is going to be nice and slow. Let's see how that looks. Okay, so we're going to pull him back and release, and it's nice and slow. And look how jerky that is. That is frame by frame how he is moving. Okay, so that's why it's appearing really jerky. It literally does not move it very smoothly. So we definitely want to fix that. So how we can do that is going over here and changing interpolate to on, okay? What that's literally going to do is it's going to calculate how much it should move in between each of those jerks, and it's going to fill it in smoothly, okay? So we did that one little change. Let's do that. And now you can see it's still going really slow, but it's perfectly smooth, okay? It's like butter. It's incredible. So I hope that kind of visually shows you why we would want to do that. So let me go ahead and get rid of that. That was just for showing you that one thing. Okay, so we are changing the direction that the bird is looking when we spawn him in and when he's on the slingshot. I also would love for him to look in the direction that he's flying after we have released him. Now, setting it once in a little method like this within the slingshot handler is perfectly fine. I feel like that does kind of fall under the responsibility of the slingshot. Maybe I could have set that method up under Angry Bird, but it doesn't really matter. But for this instance, once he's been shot, I definitely want to handle that within our Angry Bird script instead. Okay, and I've shown you awake, I've shown you start, I've shown you update. What I have not shown you is fixed update, okay? This is another one that you're really going to want to know. What fixed update does is it does not run every single frame. It runs at a fixed time interval. So fixed update runs 50 times per second. Every 0.02 seconds, fixed update gets called, okay? So that is in sync with the physics system in Unity. That is how often it calculates gravity. That is how often it calculates and looks for collisions. All of the different physics things happen on the fixed update. So if there are physics things that you are wanting to do, you want to put those in the fixed update method, okay? Now, there are exceptions to every rule, right? That's not like a hard and fast thing, but that's just a really good thing that you're going to want to know. The more that you experiment and play around with stuff, the more you will start to understand when you need to use fixed update and when you don't. So what I want to do is say in our fixed update now, we're going to do his transform.write, and we don't need to reference anything. We can say the transform directly because this Angry Bird script is on top of the game object that we actually want to rotate, right? So we can just say transform.write and it'll know, okay, we didn't tell it what transform, so we're just going to do it on the game object that this script is on top of. So we're going to say the transform.write is equal to what? We can actually make it look in the direction of his velocity. It's really, really nice. We have our rigid body component that has a whole bunch of stuff that it calculates and it stores that information for us. The velocity is included. We are able to actually set the velocity. That is one way that you can move your characters. But we can also just get that value and read it instead, which is what we're doing here. So we're just going to have him look in the direction of his velocity. Now, here's the thing. This script gets enabled, meaning this awake function gets called as soon as this instantiate method is called. It's going to create a copy of this script and the game object and all the other components on top of it, and then awake is going to get called. So we are doing that, and then we are setting his transform.write here, and we're doing it every single frame over here as well. I really don't want this to be fighting with the slingshot handler over here. It could end up with some weird and jerky behavior. So very, very simple fix for that is we are going to set up a private bool. Bools are very good for like little checks. Remember, a bool is true or false. We're going to say has been launched. And remember, again, if we don't give it a true or a false value, it's going to default to false. So that's correct. When we first do it, it has not been launched off of the slingshot. When it has been launched is when we call launch bird. So over here, we can say that is equal to true. Okay. So now we can say, let's only call this if the bird has been launched. Okay. And if you want to move a whole line of code, hold the Alt button on your keyboard and press the up arrow. You can move that line of code up and down and around. So we're going to put it in there and tab it over and get rid of that space. Okay, so now this is only going to run if he has been launched, which is great. So let's see how that looks. You can see he's jerking all over the place. What the heck is going on there? So there's two things that's causing this. He's rolling because we gave him a circle collider 2D. So he's rolling across the ground, and I don't know if he's ever going to stop because he has no friction on him. And he is still trying to face in the direction of his velocity, and it's kind of getting confused because he's moving in a really slow way because he's just rolling. So first, what I would like to do is give him some friction, and then what I would like to do is make him stop trying to face the direction he was flying in once he hits the ground or once he hits anything. So in order to give him friction, this is really easy to do, by the way, we're going to create a new folder. We're going to call it physics assets. Okay, there's a built-in asset that we can create for this. We can go in there and right-click and go to create and go to 2D and create a physics material 2D. Okay, you can set bounciness and friction here. I don't really want him to bounce. Feel free to play around with that if you want. I'm going to set this to something high like 2. Then what we can do is go to our Angry Bird prefab, and we're going to plug in our physics material 2D into his rigid body and his circle collider 2D. Okay, so let's see what kind of a difference that makes. Don't know that it made that much of a difference, but it is starting to slow down over time, so that's good. But we still have that other weird behavior going on, so let's correct that next. So we said we want him to stop facing the direction that he's looking once he's actually collided with something. How do you tell when he has collided with something? This is another built-in Unity function that is built into the monoBehavior class, right? Anything that inherits from monoBehavior gets awake. It gets start, it gets update, it gets fixed update, and it gets other things like on collision enter 2D. You can actually see there's a whole bunch of stuff here, right? The ones without 2D would be for 3D. We've got enter, we've got exit, and we've got stay, which is every single frame that we're inside a collider, right? But for this particular scenario, we want on collision enter 2D. So this is automatically going to get called whenever the collider that is attached to this game object, right? This Angry Bird is on top of a certain game object and it has a collider. Okay, so we actually need to set up another bool for a check. I'm going to say private bool should face velocity direction. Okay. Again, defaulting it to false is totally fine. When we launch the bird, yes, we want him to face his velocity direction. But when we collide with something, we want to change that to false right away. As soon as he collides with something, we no longer want him facing that direction. So we only want this to get called if he has been launched and he should be facing his velocity direction. So let's try that now. So if I launch him straight up, there you go. He just rolls instead, which is fantastic. I really, really like that a lot more. So the next problem that we want to fit, this is what game development is. You're trying to incrementally build something and solve problems along the way. That's literally all it is. So you'll see it's all working just fine with our first bird, right? But you know, there's a couple of visual things, like I would like that slingshot to fling forward. We'll handle that soon enough, but not just yet. First, what I would like to do is actually, we're still able to launch a second bird but then it's acting all wonky and weird afterwards. And it gets a little bit weirder with each iteration, and he starts going faster and faster and faster. That's because we are literally grabbing, right? If I hit pause, there's still only one clone in our game. We only spawn him in one time, so it's manipulating we're adding force to him every single time that we launch him, and it's just incrementally getting larger and larger and larger, which is making him go faster and faster. That's not what we want. What we want is for us to actually spawn in a new Angry Bird, maybe after like 2 seconds has passed from the last time that we spawned one, and then probably put a limit on how many birds that we have. So you can kind of see where this game is going. So we need to do a little bit of work here. I don't want to reposition the same bird over and over as soon as we just click within the slingshot. We need a couple of checks, and we need a timer going before we're allowed to spawn in a new bird again. So one of the first things I want to do is I want to set up a new bool called bird on slingshot. So it's going to be a private bool bird on slingshot. This is the bool that we're going to use for some of our checks that we're about to make. Okay, so let's set it to true and false in the right places, and then actually add it as a check first. So the bird is on the slingshot when we actually spawn him in. Okay, so we're going to say bird on slingshot. Yes, he is now on the slingshot because we have actually instantiated him in at our spawn position. When that is going to be false is when we launch the Angry Bird, which we actually do when we release the mouse button, right? So right after launch bird, I'm going to say bird on slingshot is equal to false. So now what I want to do is I only want to draw the slingshot and position and rotate the bird if we're pressing the left mouse button and we've clicked within the area and there's an actual bird on the slingshot. Okay, and we also only want to actually launch a bird, same thing, if there is a bird on the slingshot. So over here, I'm going to say and bird on slingshot. So that should kind of sort of fix our problem. This should make it so that we can't just keep on launching the same bird over and over. So we launch him once. The problem is we can't launch any more birds. Now we're going to need to figure out a way to make a timer count to a certain threshold. And once that timer is over, we'll spawn in a new Angry Bird. And this is where I'm going to need to introduce what's called a coroutine, which is kind of like a method, but they're a little bit different. So I'm going to go down here to our Angry Birds methods, and I'm going to close this. Okay, so most of our methods where we don't have return types, which is most of them, we put in a void, right? For a coroutine, it's still going to be private, but it's not going to be a void. It's going to be type IEnumerator. Okay, it's because it's returning an IEnumerable type. You don't really need to know what that means. It doesn't matter. All that's important is that you know how a coroutine works. Okay, so we need to give it a name. Let's say spawn Angry Bird after time. Angry Bird after time. So it's expecting something else because it's giving us an error right now. Okay, we actually have to return something in the coroutine. So the syntax around this is a little bit weird, but what we're actually going to type is yield return new wait for seconds. Okay, and we can type in a certain number of seconds here. Okay, and just for now, I'll put in like 2. Okay, and now you can see that that's no longer giving us an error. You always are going to end up typing yield return something in a coroutine, okay? You can do wait for seconds. If you wanted to have a coroutine that runs every single frame, what you would do is yield return null, okay? So there are different use cases for coroutines, and you will get to know them more and more as you go through development. Right now, all you need to know is you really don't want to use coroutines all that often, but occasionally for certain scenarios like this, they're perfect. We want to actually execute some code after a certain amount of time. So what this is literally doing is it's yielding. It is not going to run any more code beyond this point until 2 seconds have passed, and then it will pass that line and it'll run the rest of the code. There are no other methods that you can do that with, at least not any that you should be using as a beginner. Okay, so this is going to wait 2 seconds right now, and then it's going to run whatever is after. It's really not a good practice to ever just put numbers into your code. It's really always good for the sake of designing your game in a much more easy way to put it up here as a serialized field that you can easily change in the inspector. Okay, so under slingshot stats, let's set up a serialized field, and we'll make it a private float, and we'll call it time between bird respawns. So let's grab that and plug that in instead. Okay, so what do we want to do after we wait 2 seconds? We actually want to spawn in a new Angry Bird. Spawn Angry Bird. Okay, now we need to call this from somewhere. This is the other part where coroutines are different. You always need to yield return something, but you also have to call them in a slightly different way. So we're going to go up into our update method, and we're going to do it if we release the mouse button and there was a bird on the slingshot. Okay, so what we're going to do is go in here and we need to say start coroutine. Okay. Open and close bracket. Now we actually need to pass in the name that we gave our coroutine, which was spawn Angry Bird after time, and we need to do open and close bracket and then close bracket again. Okay, so every time you call a method, you do the open and close bracket, and then we need the other close bracket because this spawn Angry Bird after time was within brackets here. So it's a little bit different, but that is how you call a coroutine. So let's test that out. We shoot him, and then a new one spawns in, and we can shoot him, and a third one shoots in, etc., etc. Now, the important part is if I press pause, you can now see there are multiple copies of the Angry Bird, which is perfect. That's why they're not acting so wonky this time. So I would like to actually move these slingshot elastics a little bit after the shot, but we're going to do this in 2 different ways. I'm going to give you a really simple way right now that's not going to look as good, but at the end, I'm just going to add some optional content that if you really want to polish this up and get it looking really, really nice, then I'll give you a really nice way of doing it, but it's a little bit tougher. So we can do that right here. We can say when we release the mouse button, right, we launch the bird. Let's actually set our lines back to a certain position. So we're going to call our set lines method, and maybe what position do we want to give it? Maybe just the center position. At least that'll move them. So let's check that. All right. That's actually not too bad. It's definitely better than nothing. So I think now I want to put a limit on how many Angry Birds we can actually shoot. We're going to set this up in a really, really easy way where you've got 3 shots to try to clear out all of the piggies, which we'll create soon enough. But you'll have 3 shots to clear out the piggies, and if you don't make it, then you fail the level. So we want to be able to put a limit on the number of shots that we have. So we need to track that somewhere. And I like to track that kind of stuff, especially for a simple game like this, on a game object called Game Manager. Okay, so I'm creating a new game object called Game Manager, and I'm actually going to set up a script with the same name. Okay, we're going to drag and drop that in. You'll notice that this one does not have the normal icon that the other scripts do. That's because having a script called Game Manager is so common that Unity actually already has this little built-in thing where it puts in this gear instead, because it's just very common to have a game manager that manages the state of your game. So this is where we're going to tell the game to like reload the level if you fail and all that good stuff. But we're also going to track how many shots you've done here. So let's get rid of this boilerplate code. Now, I don't think I've shown you this before, so it is worth showing you what public variables actually do. I've shown you a whole lot of different private variables with serialized fields. If you set up a public variable, it's actually going to act the same way. You are also going to be able to change things in the inspector. I didn't tell you that at the beginning because it's still a better practice to make your variables private and do serialized field if all you're wanting is the functionality to actually change things around in the inspector. The reason that we would make a variable public is because we want to actually be able to modify and change it in another script. So here I'm going to go ahead and set a public, and this is going to be of type int. We don't need a floating point because it's just the number of shots. It's always going to be a whole number. So we're going to say max number of shots. And we're going to set that to 3. Okay, and you'll notice that I started this one not with an underscore like I usually do, but I started it with no underscore and a capital letter. That's again just a part of the naming convention that I follow. You can Google proper coding naming conventions if you really want to know. It is a good habit to get into, but when you're learning, and especially when you're working by yourself in the early stages, it really doesn't matter. You don't want to get into bad habits. So it is something that is worth looking into and figuring out how to do it, especially for the sake of being able to read other people's code really well online. Okay, and we're also going to set up a private int called used number of shots. So there's 2 methods that I'm going to want to set up in here right now. I'm going to want to be able to actually use the shot and increase this counter here. And then I want another method that's going to return a bool type to tell me whether or not we still have some shots remaining. So let's set up a public void called useShot. So all we want to do in useShot for now is increment our used number of shots. Okay, and a nice little short way of doing that is saying used number of shots plus plus, and then semicolon to end the line. Okay, that is literally the same as writing used number of shots is equal to whatever it was before plus 1. Okay, it is literally the same thing. It's just much shorter writing it this way. So it makes sense to get into the habit of writing it this way because that is how every other programmer does it. And then we are going to set up a public bool method called has enough shots. And remember that when we set up a method with an actual return type, meaning it's not void, it's going to give us an error until we give it a proper return type. So we're going to say if the used number of shots is less than the max number of shots, then it is true that we have enough shots. Else, we're going to return false. Okay, so let's go back to our slingshot handler for a second. So we spawn an Angry Bird at the start of the game, and then we spawn another one after a certain time after we have shot one. So really, I want to wrap this in some logic that checks, do we have enough shots? Because if we don't, I don't want to be calling this again. Okay, so I don't want any of this to run unless we have enough shots. Now, how are we going to reference this game manager here? I could go up here and I could say serialized field and I could plug in game manager, right? Because you can't actually call any functions until you actually have a reference to the script. You know that by now. I'm going to show you a neat little trick, and maybe I shouldn't be doing this for a beginner, but that's okay. I'm going to show you what is called the singleton pattern. What you really need to know about this pattern is this is only ever to be used if you know with 100% certainty that you're only going to have one copy of this script in your game ever. This would not apply to Angry Bird, right? Because we have multiple copies. It might not even apply to Slingshot Handler depending on how we handle different levels. We might end up having different copies of this. It's hard to say this early on. But Game Manager, we're only ever going to have one of those. It's going to manage the state of our game. We know we're only ever going to have one. And it's beyond beginner level, but it's really handy to have in your pocket. But I do recommend that you read up on the singleton pattern and the pros and cons of it once you're a little more comfortable with programming. So we're going to say public static game manager, and we're going to set it up as an instance. So basically within the game manager class, we are setting up another variable. It's going to be a static variable, which means it's not going to change. And we are assigning this game manager variable type to something called instance. Okay. So we need to assign what instance is. We're going to do that in the awake function. And we're going to say if instance is equal to null, meaning if it hasn't been assigned yet, which everything is always null at the beginning, if it's a script type, until we actually assign it to something, it's going to be null. So if it's null, meaning it hasn't been referenced yet, then we're going to say instance is equal to this, What does this mean? This literally just means this script that this is, okay? So we're just creating a variable of type game manager. We're calling it instance, and we're setting instance to this script to a static type, okay? Meaning once we've set it, it's not going to change. Now, static types are nice because you can reference this even without actually having a reference to the game manager object. That's why it's called the singleton pattern. We are only ever going to have one copy. So let me show you how this works. That was the whole setup for the singleton pattern, by the way. We're totally done. So we're going to go back to our slingshot handler, and we're going to say if game manager dot instance dot has enough shots. So that is how you are able to, we don't have a variable set up for our game manager anywhere in this script. Because we used the singleton pattern, we are still able to call this function even though we don't have a reference to it, because we are setting an instance and it's a singleton. So there's only ever going to be one. So we don't really need to worry about having multiple copies. Okay, so if we have enough shots, we actually want all of this stuff to run. Okay, now, after we launch the bird, we want to actually use a shot. So we're going to say game manager dot instance dot use shot. So we're checking to see if we have enough shots before launching any of this stuff. Then we're actually using the shot again. So before we call this coroutine here, which is going to spawn in a new bird, we want to check it one more time because it just changed. So again, here we want to say if game manager dot instance dot has enough shots. Only then do we want to actually run this coroutine. And you'll see I've got an error there. That's because I forgot the open and close brackets. Okay, and I'm just going to organize this a little bit better. Okay, so let's test that and see if that works. Okay, so you see our max number of shots is 3 there. So we're going to go ahead and check. So that's 1, 2, 3. Awesome. And no more birds get spawned in at that point. So at this point, we would check, okay, have all the piggies been destroyed? If not, we failed the level. Now, it would be really, really nice if we had some sort of visual indication as to how many birds we have left. Having just an arbitrary number in your head isn't really good game design. We want some sort of visual. So what we're going to do is set up some icons at the bottom left of the screen, and it's going to show when they've actually been used. So you get to learn about UI next. Okay, so anytime that you want to set up a UI, if we don't have one already in our scene, what we need to do is right click in our hierarchy, go down to UI, and we need to create a canvas. Okay, a canvas is what is going to render and actually show any of our UI images, because UI is handled differently from sprites. UI is always drawn on top of all sprites and everything else. Okay, so to show you an example, what I'm going to do is create an image as a child of the canvas. So again, I'm going to right click on the canvas, go down to UI, and I'm going to create an image. Okay, that's going to put this little white square in the middle of our screen. So what I would like to do is actually change this so that we are scaling with the screen size, literally meaning if we change the size of our screen, that the size of the image is also going to change along with it. That's pretty standard for a lot of UI stuff. So I'm going to, the reference resolution is going to be 1920 by 1080. So let's put that in there. Now we're actually going to have 3 different icons. So what I want is not an image yet. What I want to do first is create an empty, and I'm going to call that icons. Okay, and within that, I want to create 3 different images. So we'll create an image, icon 1, duplicate it 2 times and rename it. Okay, so right now they're all on top of each other. So what I would like to do, these are all positioned in the center middle. You'll notice that these are not regular transform components that our normal game objects have. These have what is called rect transforms on them, which is specific to the UI interface. So you can just position these manually. You can change the X and the Y on all 3 of them. But to make this just a little bit easier, what I would like to do is go to icons, and I'm going to select this center middle here. And I want these to be on the bottom left here. So we want to change the position and the pivot to be the bottom left. The pivot is literally going to be at what point does the image scale from. If you think about it, if you want to scale a picture from the center, then it's all going to blow up regularly, right? This one, it's going to set the pivot to the bottom left. We don't actually need that. We're not going to be rescaling these at all. So let's actually just hold the Alt and we can go ahead and click the bottom left like that. Okay. Now all three of them are in the bottom left. Now, again, I could go ahead and like position these manually, but I want them to be evenly spaced apart. So let's add what is called a horizontal layout group, and let's space them apart by something like maybe 20 will do. Okay, that'll just evenly space them out. And now let's actually just, that's right in the bottom left corner. So let's actually just move that over a hair, maybe up to 80, and then move the Y up to 80 as well, maybe 70. Awesome. Now let's actually plug in our Angry Bird sprite for this. Just that one. Same with these two. You can do them both at the same time if you highlight them both. There we go. We've got three different icons here. By the way, you might notice something a little bit weird in your scene view as soon as you create a canvas, right? If we actually press F on one of these icons, it's huge compared to the size of our world, right? This is just kind of one of the weird ways that Unity handles UI, and they actually they have a whole other UI system now called UI Toolkit. But it is still in production, but it will be their new system that eventually the developers will be using. But UI, this legacy system, this is not going anywhere. This is still going to be very, very useful for you to know, especially for small, simple games like this. This method is far easier. But you'll see if we zoom all the way out to the point where it's so small we can hardly see our world, here is our actual canvas, which represents the size of our screen, right? So we've got our three icons here down in the bottom left. So it's a little bit weird. It adds the canvas into our game world as if it's actually there. If that bugs you, like you can click on the eye icon so that you can't see it. So it's not really that big of a deal, but it is a little bit weird and I figured I should show you. Okay, so what we actually want to do is I want to go ahead and just darken one of these icons at a time each time we use a shot. And again, we are going to do that with code. So we are going to set up a new script, C# script, and we're going to call it icon handler. Okay, let's attach that. And let's open it up and get rid of the boilerplate stuff. Okay, this is going to be a really, really short script. There are only two variables we need. So we're going to set up a serialized field, private, and we want this to be an image. But you can see that image is actually not a type that we are able to select. We look here and it literally doesn't exist. That is because we need to go up here and we need to add the using Unity Engine .ui namespace. As soon as we do that, we can go down here and now we can add an image. Okay, so private image, and we're going to say icons. But here's the thing, this is only going to set up one, and we don't want to set up this line of code multiple times. So what we want to do is create an array of icons. Okay, so how we do that is after the variable type, we're going to do open and close square brackets. Let me show you what that looks like in the inspector. So what that's going to do is create this drop-down variable here. We can click on that and it's going to say list is empty. I can add to that and I can add as many as I want. The icon number changes automatically here, and you can see element 0 through 4. And again, remember I told you that arrays start by counting from 0. So 5 elements means 0 to 4. Okay, so that's what an array is. It's basically a list of stuff. So what we actually want is we want to have 3 of these. And we just want to assign those icons one at a time. So I'm going to do it this way. Okay, let me show you a faster way, because sometimes you can actually end up having an array that has dozens and dozens of things. So maybe you don't want to do it that way. What you can do is right click here and click properties. All that is literally going to do is create another copy of this window over here and something that you can move around. That's just because every time you click on something, the inspector changes. But now over here, we've still got a reference to it, okay? We can literally just highlight all three of those icons and drag them to the icons button right there, and that'll just assign all three of them. And now you can close this and you can see it changed over here as well. So that's just a little bit faster. Okay, but that's what an array is. It's a list of stuff. So now we've got a list of all three of our icons. Now I also want to set up a color variable. So just like any other variable, we're going to do serialized field, private color, and we're going to call it used color. Okay, and we want one method and it's going to be called use shot as well. So we're going to say public void use shot. And we want to pass in an argument. It's going to be an integer type because it's going to be what shot number is it. So we're going to call it shot number. All right, so you're about to learn what's called a for loop. And a for loop is how you are actually going to iterate through every single individual image within this image array. Okay, so we're going to type for and then tab twice. All right, so this syntax looks really, really weird and intimidating at first. So this is doing a couple of things. First, it is setting up a local variable of type integer. It's calling it I, okay? That's short for index, basically. And it's assigning it to be 0 right away, okay? Then after that, it's going to say, okay, if I is less than something's length, we need to plug something in here. It's going to be our array's literal length. So we're going to type in, our icons dot length. Length is going to count the number of items in the array. And this does not start from 0. If the array has 5 items, then it's going to return 5, okay? So it's saying if the index is less than the icons.length, in this case, it's going to be 3. So if I is less than 3, then it is going to run what is in these brackets, okay? And then every single time it completes the loop, it's incrementing I. Remember over here in Game Manager, we did plus plus over here. That's incrementing it. So this in one line of code is creating a variable and assigning it. It's creating an if statement and it's going to say, okay, if that is true, then this is going to run. How many times is it going to run until this length? And it's incrementing this to make sure that that gets accounted for. So basically we already know because this icon has a length of 3, what we put in here is going to run 3 different times. So what we want to say is if our shot number that we pass in is equal to our index from our for loop plus 1. Why do we need to add plus 1? Because the index starts at 0, but our shot number starts from 1. So in order to properly compare them, we just need to add 1 to the index. Then what we're going to do is actually change the icon color. So how do we know which one to change? What we're going to do is say icons, and we can actually reference which one in the array by putting in square brackets the index that we are on in that for loop, okay? So we're going to say icons of the current index dot color is equal to used color. So this loop is going to run 3 times. First, it is going to look at array 1, literally meaning element 0. So the first time it runs through it's going to say, is the shot number equal to the number 1? If so, then change the color. No. Is it number 2? If so, change the color. No. If so, number 3, change the color. Okay. So it's going to run 3 different times, but that could be a little bit wasteful. We don't necessarily need that. So as soon as this is true, we don't need it to continue because it might actually happen the first time. If that's the case, we're running this 2 more times for no reason. That's just a waste of our computer's memory. So what we can actually say is return right here. So if our shot number does equal the index, then we change the color and we return, which means stop running the for loop. You don't need to continue, just return means stop. Okay, so where are we going to call this use shot? Because currently, again, it's not doing anything, right? We set everything up in the inspector, but until this gets called, it's not going to do anything. So in our game manager, we have use shots here. So this seems like a really good place. That's already being called. Let's just go ahead and call the icon handlers use shot from within this method here. Now I want to show you just another way of grabbing a reference to a component. It's totally fine if right here in game manager, you want to do a serialized field and find the icon handler and assign it that way. But I'm going to show you a different way. So we're going to set up a private icon handler. We're going to call it icon handler. Okay, so we only need to do this once, and we want to do it right at the beginning. So we'll do it in awake after we assign the instance to this class. We're going to say icon handler is equal to GameObject dot find object of type. I'm going to go down here. You can tab it to finish it. It already knows what I want to do. We want to find object of type icon handler. Okay, and actually it looks like I don't even need the game object there. Yeah, you can just say find object of type icon handler. Okay, so that's going to look through every single game object in our hierarchy, and then it's going to find one that has an icon handler attached to it. So this one's a little bit more resource intensive, just by a teeny bit. It happens in like fractions and fractions and fractions of a second. So don't think that this is going to slow your game down. It's not. It's just there are more efficient ways of assigning references to stuff. But I wanted to show this to you. And for the purposes of a really small game like this, you are not going to slow the game down by doing a simple little call like this. Okay. But that now gives us a reference to the icon handler. So now in use shot, I'm just going to go down here and say icon handler dot use shot. And we have to pass in what is the shot number. We need to pass in the used number of shots. Okay, so let's go back to the inspector. And let's actually change our used color. I don't want it to be full black, right? Because if I assign it to full black, that's going to look like that, which looks a little bit weird. So maybe let's just make it like a dark gray like that. I'll copy that hexadecimal, put it back to full white, and then paste that in here. And don't forget to drag the alpha up. Whenever you assign a new color in the inspector, it's going to give it an alpha of 0, which means transparent. Alpha affects transparency, so you want alpha to be full. Okay, so let's test that. Boom, we used a shot, that guy goes gray. Used our second shot, that guy goes gray. Third shot, he goes gray. And then no more birds spawn in. Perfect. It is worth mentioning, I've probably been doing it and been forgetting to say it. We are working within a scene here. All of your scenes data is contained within this scene right here. You can have multiple scenes in Unity. That's why we have this scenes folder here. As you're working through your hierarchy, you want to be saving your scene. We just go to File and click Save. It's going to save our scene. So if you want to make sure that you're periodically doing that in case your computer crashes, you don't want to be losing any of the work that you've done. Just got myself a new coffee. Okay, so a lot of the base mechanics for this game are done, so I think it's actually time to get some piggies and get some blocks going on in this game. So the blocks are going to be really easy. Let's do those first. So it looks like I cut out 4 different blocks, so let's just drag each of those in. By the way, you have to drag them in individually. If you try to drag all of them in at once, this box is going to pop up. It's going to think that you're trying to create a new animation if you do that. So that's not what we're doing here. So just do it one at a time. So the way that Angry Birds works is we are going to want a collider on every single one of these blocks, as well as a rigid body, because right, we want physics applied to these. If they end up falling, we want gravity applied to all of them. So what's nice is because we cut them out nice and tight, if we add a box collider 2D to one of these, this one here, for example, it's already going to snap nicely right to the edges. So it's going to size it perfectly based on how we cut it out of the sprite sheet. So let's add a box collider 2D and add a rigid body 2D as well. I'm just going to get rid of any angular drag. So you can set all of these to interpolate. It really depends on what you're going for here. On a mobile device, that might end up making it a little bit more resource intensive. It definitely has more calculations to do if you turn interpolate on. So it might be something that you actually want to play around with. I am going to turn interpolate on for all of them, just because I would like the physics to look nice and smooth. but you might want to try it with and without, especially on your mobile device, which we are going to build this onto at the end. All right, so that's good. So let's do the same for all 3 of the rest. And a box collider and a rigid body, and I can do it to all of them at the same time and get rid of the angular drag and set interpolate to interpolate. So I don't know what to call these. I'm gonna do like hollow, skinny, tall block. I don't know. This is gonna be solid, thick block, solid square block, maybe hollow square block. So I am actually going to set all of these as prefabs as well. Now, we're not actually going to be spawning these in with code, at least not anywhere in this tutorial. But the other advantage of having prefabs built is now, if I want, in my scene view, I can literally just drag and drop prefabs from our prefab folder there into our game, and it's going to spawn in a new copy of that with a box collider and a rigid body 2D with all of those properties already attached, which is really, really nice. So you can start building out your levels very quickly by just dragging and dropping in different prefabs. So I'm just going to build a level really quick. And put him over there. Now, this is going to be really wobbly, so I'm going to hit play to see if it actually balances. It does. Very cool. So that's our blocks. Really, really easy stuff. So let's set up our piggies next. So I would actually, before I drag him in, I would like to clean this up just a little bit. This is starting to get a little out of hand. So I'm going to create an empty called blocks and just put all of our blocks inside that guy so that we can minimize him. By the way, when we put the canvas into the world, I forgot to explain, it's going to also, whenever you create the first canvas in your scene, it's going to create an event system along with it. We're not going to be using this event system in this tutorial, so it's outside the scope, and I'm not really going to explain what it's for. You would end up using an event system if you were navigating menus and you wanted to, be able to control which buttons are selected and all that good stuff. It comes in really, really handy for that. But leave it in there, like it's not going to do anything. You just don't need to worry about it. So creating our piggy, we're going to drag and drop him into our hierarchy, and I'm going to scale him up to 2 as well and rename him to piggy. Okay, so he also, actually, I'm not going to put a circle collider on him. I'm going to put a capsule collider 2D on him. He is the perfect shape for a circle collider, but the problem is as soon as these are not perfectly at 90 degrees exactly, he's going to roll right off if we put a circle collider on him, and that's not exactly what we want. So we're going to put a capsule collider on him instead, which looks like a perfect circle because at the start it is. I'm going to change this to horizontal though, and you'll notice that as I reshape this around him, it's going to get just a little bit flat around the top and the bottom, right? Kind of like the shape of a pill. So that's exactly what we want. We want it to be just slightly flat on the bottom so that he's not so prone to just rolling right off of these blocks. Okay, and we also want him to have a rigid body 2D. We want him to be affected by gravity. We'll get rid of any angular drag, and I am going to interpolate him as well. I'm going to rename him to Batty, actually. And I'm going to create a new script called Batty and put it on him. So really what we want this script to control is how much health does the Batty have. We want it so that we're going to calculate based on a certain velocity how much damage is he going to take when something hits him. Not just the bird, but also if any blocks fall on top of him. If he falls off the top and hits the ground, we're going to apply damage based on velocity because that is basically how Angry Birds works. So let's get that set up. So health scripts are very, very, very easy to set up. What we want is a serialized field, and we're going to do private float max health. We're going to set that to 3. And we want a private current health as well. Okay. In our awake function, which we know when that's called now, we are going to set our current health to be equal to our max health amount. So at the start of the game, our current health is always going to be completely full. Now we want to set up a public void damage baddie function. And we don't exactly know what the damage amount is going to be in this function yet. So we're just going to put in an argument for a float and call it damage amount. So what are we going to do? We're going to say that our current health, now you can do minus equals damage amount. This is very, very similar to the incremental shortcut that I showed you over in the game manager here when we incremented the used number of shots up. What this is doing is saying, okay, it's the same thing as saying current health is equal to current health minus our damage amount, okay? But instead of having to type out all that extra stuff, we just say minus equals damage amount. And then we're going to say if our current health is less than or equal to 0, well, then he's going to die. So let's set up a die function, private void die. Call that there. So what we're going to do in the die function is we are actually going to destroy this game object in Unity. That's literally going to get rid of it from the hierarchy view, only in play mode, mind you. It's not actually going to delete it out so that it's never there again. Okay, so how do we calculate our damage amount? You know, in most, this is actually kind of complicated because in most types of games, it's a lot more simple, right? You got hit by a sword or you got hit by a bullet and you just literally pass in the damage amount that you have attached to that attack. In this scenario, we want it to be based on velocity. So it's just a little bit more complicated, but we still have a nice, easy way to do this. So our baddie has a collision on top of him. So we are going to add an on collision enter 2D. Where are you? There. Okay, so we want to be able to detect whenever he collides with anything. And then we're going to calculate what was the velocity of the thing that he hit. So we're going to say float impact velocity. And again, we're just setting up a local variable here. We don't need a copy of it anywhere else. And what's nice is this on collision enter 2D, it actually gives us a collision 2D variable type, and it passes that right in. And this gets called whenever we enter with something. So this is actually storing information about the other collider that this guy's collider hit, okay? So we're going to say collision dot relative velocity dot magnitude. Okay, so if we were to do relative velocity, what that's going to do, that's actually going to return a vector2 type. That's not what we want. Magnitude is just going to turn that into one whole number. So, you know, this is going to happen with absolutely anything, even if, you know, when we set him like a millimeter above this box right here, even if there's just the tiniest little space, it's still going to damage him just a little bit. So maybe it would be smart to set up a damage threshold. So let's set up a serialized field called private float damage threshold. And we'll say something like 0.2, something really small. So over here in the on collision enter, we're going to say if our impact velocity was greater than that damage threshold, then we will call damage baddie. So that little tiny things like what I just mentioned, that doesn't actually end up pulling health away from this guy, because that's not really what we want. And we'll pass in our impact velocity. Perfect. So, okay, let's throw a couple of baddies in our scene and check that out. So I'm going to turn the baddie into a prefab as well so that I can very easily create copies of him. So I'm going to put one right here, maybe another one behind the tower, and maybe one little cheeky guy that's hanging out up here. Oh, he's going to cause problems. Okay, hold on a second. Maybe it'll even out if I actually put this guy over on this side. Let's try that. Oh, that's working. Okay, I like that a lot, actually. All right, perfect. So let's go ahead and test this. So we'll, boom. Perfect. Okay, you saw a couple of them disappeared. This guy here is still alive, but if we, boom, right, he ends up dying, okay? So what we were trying to accomplish with this game is, okay, we've got 3 different shots. Can we kill all of these baddies with our 3 shots? And we don't necessarily want to make the game fail right after we use the 3rd shot, right? Because you want to give it a couple of seconds in order to actually see, okay, maybe we hit this. We need to give it time for the actual physics to occur and check if any of the baddies end up dying. And then if that's not the case, then we'll end up checking, did we fail or did we succeed? So let's go back to our game manager just for a second. So I'm going to add another method in here called check for last shot. Okay, so if our use number of shots is equal to our max number of shots, then this is the last shot and we want to do something in here. And what we're actually going to do is just call check for last shot every time we use a shot. Okay, so that's already being called. So if it is in fact the last shot, we said we wanted to wait just a little bit in order to actually give the physics some time to work themselves out to see if, oh, maybe we just need that one block to fall on the piggy's head and then we'll win. We want that to actually be a win condition. So we want to wait, which means we're going to do another coroutine. So we are going to set up a private enumerator check after wait time. So let's set up a time up here at the top. I'm going to create a serialized field, private float, seconds to wait before death check. Let's put in 3 for the default. Okay, so at the start of this coroutine, we're going to say yield, return new, wait for seconds, and we'll pass in the amount of seconds we just set up. After that, we want to check, have all the baddies been killed? Right here is where we're going to call that coroutine. So we can say start coroutine, check after wait time. Now we need a way to actually keep track of how many baddies have we killed. Okay, and I introduced you to arrays not too long ago with the icon handler, remember? Now I want to introduce you to what's called a list, which is very, very, very similar. But what's nice about a list is at runtime during code, we can add things to the list or remove things from the list. So if you want your array or your list to be dynamic, then a list type is the one that you want to be using. So I am going to set up a private list. It's putting in T here. Remember I told you earlier with get component, you're going to see these whenever it's a generic type. That means literally you can put in any kind of variable type you could possibly imagine. We could put in a list of ints. We could put in a list of anything. But in this case, we're going to put in a list of baddies. And we're going to call that baddies. And that's going to be equal to a new list of type baddies. Okay, so this is private. We are not assigning this in the inspector because we don't know how many baddies are in the game. We are just dragging and dropping them into our scene. We might build this game to have multiple levels and have different amounts of piggies in every single one. So what we actually want to do is find out how many baddies we have at the start of each level. So I'm going to do that right here in the awake function. So first we need to find all of the baddies. So what we are going to say is we're going to set up an array of type baddies called baddies, and that is going to be equal to find objects of type, okay, that one there, baddies. Okay, so what that is going to do is in the awake, it is going to find all the copies in the game that it can find of baddie and assign it to this array variable of type baddie called baddies, all right? Now, that did not assign anything here. This is a list. This is an array. So what we now need to do is a for loop, which you are now familiar with. Whoops. For, there we go. Okay. So we're going to replace length with baddies.length. So again, what a for loop is doing is it's going to run this loop for every single baddie that the game finds. Okay, so for each baddie that it finds, we're just going to say baddies, which is our list up there, dot add. What are we adding? The current index of baddies from our array that we just found by using find objects of type. So that will finally, at the start of the game, it's going to find all the baddie objects, and then it is going to add them all to our private list up here. Now we actually have a list of baddies in our game. So I'm also going to create a method in this script here because we made this private. Instead of making the list public and directly modifying it from another script, I'm just going to create a method that removes a baddie from the list. And that should be public void remove baddie. Okay, and we're going to be removing a type baddie, and we'll just call it baddie. We don't know what instance it's going to be just yet. So again, we put in an argument so that that logic can be filled in later. So we'll reference our baddies list and say dot remove. It wants us to remove a baddie item, so we're just going to remove the baddie argument that we just made. Okay, now in our coroutine here, we actually have a way to check that logic. We can say if baddies dot, no, so for arrays, it's dot length. For lists, it's dot count. They both return, if the list has 5 things in it, it will return 5, okay? So if baddies dot count is equal to 0, meaning there's nothing left in the list, then all our baddies are dead and we win. Else, we lose. Okay, because remember, this check after wait time is happening after we have used our last shot. So the only other logic we need to fill in here is we need to fill in what the win and lose conditions actually do, and we need to call remove baddie from somewhere. But there's one more thing. I don't want to confuse you with by adding too much all at once, but right now, every single time we use a shot, we're checking for the last shot. And if it was the last shot, then we're running this coroutine to check if our baddies are all dead or not. But here's the thing. We might also win before we check for that, right? So we also need to check to see if we won every single time we remove a baddie. So we're going to create a method called private void check for all dead baddies, and we'll say if baddies.count is equal to 0, then we'll win the game. Okay, so that should also be called here. So I'm going to create another region, win, lose, and region. Okay, so down here we're going to do a private void win game and a private void lose game. Okay, so we'll fill in the win here. And lose game here. And also win right here. So in order to finish off this bit of functionality, the only thing left we have to do is fill in the win game and the lose game and actually call remove baddie from somewhere. So let's do that first. What we're going to do is in our baddie script over here, whenever this game object dies, before we destroy it, because once we destroy it, no more code is going to run, so it needs to be before, we're going to say game manager.instance.remove baddie, and we're going to pass in this, because remember, it's looking for an actual variable type of baddie, and this is the baddie script. So we can literally just pass this in. That's going to remove this copy of the baddie from that list. So for now, just to test this, let's go ahead and just do a debug.log, which is always a really good way to test stuff. We'll say debug.log win game. And down here, we'll say debug.log lose game. It's a lot of stuff we just added in with code, so let's check it and make sure everything is working correctly. Okay, boom, killed one of them. and the rest are dead, and we won the game. That was before we used all of our shots, so let's make sure that we're able to lose as well. I'll just shoot away, 2, right? And remember, it's going to wait. So even if I do this, right, we still won because 3 seconds had not gone up yet. But this time I'll actually just miss all 3. Okay, and it's going to wait 3 seconds. And then we lost the game. All the piggies are still alive, right? So that is working. Awesome. Okay, so let's handle the lose game first. All I want to do is just reload the scene or reload the level if we lose, okay? So in order to do that, we need to add a new namespace up here called using Unity Engine.scene management. Remember I said that everything in our hierarchy right now, this is all within a scene called sample scene. That's just the default scene that it gives you. Big games that you end up making are very possibly going to wind up having many, many, many scenes. A lot of people use different scenes for different levels, but you can end up using scenes for a lot of different things. But for this game, it's very simple. We're just doing everything in one scene. So we're literally just going to reload this scene as it is right now. Okay, so when we lose the game, we want to reload the scene. And so how we do that is we say scene manager dot load scene. Okay, it wants an int of what the scene build index is. I really, we could type in 0 there because that is the index of what this scene is. Let me show you that really quick. If you actually go to File and go to Build Settings, you'll see up here our scenes in the build. This is literally how you build your game so that you can run it on your computer instead of just running it in Unity. These are our scenes right now. And every time you add a new scene into your game, you need to drag and drop it into this scene if you want it to build with that scene. And our index number is right there at 0. So I could do it this way. That's just again, we don't really want to get into the habit of hard coding anything. With a small game like this, it is fine, but it would be better if we actually knew how to dynamically grab, okay, what scene index is this, and pass that in so that we just literally reload the same scene. So to get what scene this is, we're again going to say scene manager dot get active scene, open close bracket because that's a method, dot build index. Okay, so let's test that out. All right, like if I go here and I take him out, but then I end up failing, I end up shooting this guy over here, and I'm shooting this guy over here, everything should get reset. Boom, just like that, right? Okay, so that's great. What I would like to do when we win is I want to make it so that the slingshot, you can't use it anymore. The script on there is no longer running to save some resources, and I want some, text and a restart button to pop up on the screen. So in our canvas here, I would like to create a new empty and call it restart screen. So this is really, really simple. There are 2 images that I want. So we're going to right click, add an image, go ahead and just duplicate that. One is going to be the text image. It's not actual text. It's just a sprite that we grabbed from the sprite sheet. And the other one is going to be the restart icon. Okay, so pull that one up here. So the text image is going to be, where is it? I believe it was this guy here in the shockwave. Yes, it was. That little congrats there. I'm going to drag that sprite in. Okay, and I'm going to hit set native size so that it doesn't get all weird and stretched the way that it was. And for this restart icon, it's going to be the same thing. Let me just find it. I think it was within this buttons sheet. Yes, it was. Yeah. So for the restart icon, drag and drop that in, and you can hit set native size again. It barely did anything though. Okay, so we only want these to be showing when we have actually won the game. So just make this easy. Let's go ahead and deactivate the restart screen. And what we'll do is we'll go back to our game manager. Let's get a reference to that. We'll set up a serialized field of type GameObject, and we'll call it restart screen object. Okay, and when we win the game, we'll say that dot set active true. Okay, so let's plug that into our game manager here. Let's press play and let's make sure we win. Boom. There we go. That is popping up. Okay, so the other two things we want to do is I'm still, even though the game is over, I'm still able to move this Angry Bird around. That seems a little bit weird. So we don't want that. And then we also want to be able to actually click this as a button here and then actually reload the scene from that. So handling the first problem first, we're going to add one more serialized field, private slingshot handler. We want to go down to our win state. Say that dot enabled is equal to false. You'll notice here that with GameObject, I have to use dot set active, which is an actual method, but on the script, I'm using dot enabled. Really what's happening is with dot enabled, I am disabling this little checkbox here, which is disabling that script. If I play the game with that disabled, nothing is going to happen because that script is no longer running. So changing whether or not a script is enabled is going to toggle that checkbox there. Toggling whether or not a game object is active is toggling this checkbox up here, which is completely going to deactivate it from the scene. You won't even see anything, right? You're not going to see the sprites. You're not going to see anything. Okay, so that's the difference. By disabling just this script, the slingshot itself is not disappearing. We're just stopping all of the code that is being run on this slingshot because it's not necessary at that point. Okay, and on the restart screen, let's enable this just for a second. On the restart icon, what I would like to do is add what's called a button component to that image, which is automatically going to make it interactable. Okay, that now means that we can click on it like it's a button. And all of these defaults are fine. These just change its color very slightly based on whether you click on it or whether you're highlighting it. What we want to do though is add an event to this onClick method here. So we're going to click plus. So first we need to put in, okay, what game object is the script attached to? We're wanting to call this method here, although that's a little confusing. It's called loseGame. I think I'm going to do Control-R so that I can rename it. I'm going to rename this to restart game instead. Okay, doing Control-R just made sure that it renamed in all the right places. Okay, so I'm wanting to call this restart game method from the event. So it's on top of the game manager script, which is in our game manager game object. Okay, so I'm going to drag in game manager, go to the game manager script, and find the restart game. And it's not there, probably because I forgot to make it public. So let's change that to public. Okay, so game manager, now it's there, restart game. So when we click on this button, that method is going to get called. Okay, so to put it back to where it was, let's unselect that, hit play. Let's make sure that we win. And we got an error. What happened there? Oh, it's because I forgot to assign the slingshot handler script. So let's attach that, try it again. Awesome. All right, so I'm no longer able to select on the slingshot, and you will notice that the Angry Bird actually spawned in after we won. That is because we are spawning in an Angry Bird from a coroutine. Even if a script is disabled, if there is a coroutine running, it will finish. Okay, that's very important to know. Coroutines are a little bit more complex than most other scripts, so it kind of runs in parallel with everything else. But this is totally fine in this scenario because at least I can't shoot him. And now if we click on that button, we're able to reload the scene, which is awesome. Okay, now you could stop the tutorial here because you technically do have a working game, except I said that we were going to make this compatible for mobile as well. Now, publishing to Apple is a lot more involved because I don't know of any easy way to do it for free. Android, unfortunately for Apple users, Android is a lot more easy to just build, and you can put it in your Google Drive or whatever and just download it directly onto your phone and it'll just work. But we do have a little tiny bit of refactoring to do if we want to be able to make this work for mobile. So we're going to do that now. And let me show you why. Okay, in our slingshot handler, we are literally grabbing mouse.current.left button, right? This is all built-in stuff because we added the input system namespace up here, okay? Now, we need to set this up in a more appropriate way to work on multiple different control schemes, which means we are going to need to set up an input asset, okay? So let's set up a new folder and we're gonna call it input. It's just the very one at the bottom here. It's called input actions, okay? So create input actions, all right? And we're gonna call it controls, okay? So click on edit asset. That's gonna open up this window. I like to dock it down here by the game view. All right, so we are going to set up some actual proper controls now. So we're going to start by creating an action map. So this is just, in-game controls. Usually I end up just having in-game controls and UI controls, but it really depends on what type of game that you're working on. You can often get away with just having one action map. Okay, so over here, I just deleted out the default one that it gave you. We're going to set up what is called actions, and we only need 2 here. Okay, one is going to be our mouse position. This is going to be mouse or touch position. Okay, I'm just calling it mouse position. And the other one is going to be just mouse or touch. Okay, so mouse position is going to be, I want to set this from, what did it default to? A button, I think. I want to change it from a button to a pass-through. I like using pass-through because it gives you this initial state check, which means, okay, you can actually check where the mouse position, or in the case of mouse over here, we can actually check if you're clicking the mouse button down before the game starts, it will actually do an initial state check and still return the proper values. It doesn't need to initialize anything first. So this is the way I prefer to do it. But okay, so pass through for both with initial state checks, but for mouse position, we want a control type of vector2. But for the mouse here, a button is perfectly fine because we just want to detect, okay, are we clicking something or are we touching something on our touch device? Okay, so our mouse position, we're going to have 2 actual actions in here. Every time you create a new action, it gives you 1 new binding. Our first binding is going to be for our mouse. So let's add our mouse position, okay? And then we're going to add another binding, and this one is going to be touch screen position. And for our actual mouse here, we're going to go to mouse, and we're going to say left button. And another binding, we're going to go back, go to touch screen, and we want press single touch. Okay, and don't forget to press save asset here. Okay, so this is a controls asset, but we're not able to actually read this right now. So we actually need to set up a little script, and it's not going to be too bad, to actually detect some of those things that we had built in before, like was the left button pressed down. Now that we've added multiple control schemes, we can't just use this. We're going to set up our own. So we're going to create a new script, and I'm going to call it input manager. Okay, so on our game manager, I like to create a new empty under there and call it input manager. This is just usually what I do. It's not really a right or a wrong way. This is just my preference. I'm going to add an input manager to this. I'm also going to click add component and find what's called player input. And this exists because we installed the input system package. Okay, so what we want to do is actually drag in our controls actions here. That's just going to make it really easy to reference this stuff here that we just set up. So let's open up our input manager. So we are still going to need to add the using Unity engine.input system namespace at the top. I keep getting tangled in my cord here. Okay, so we're going to set up two private input action. Okay, private input action, which is a reference that has to do with the input system. What did we call these? Mouse position and mouse. Okay, so we're going to do mouse position action, and the other one's going to be a private input action, mouse action. Okay. Now, we only ever want one player input in our games, so I'm going to reference that as a static so that we don't end up having multiple instances of that. So I'm going to say public static player input, and I'm just going to call that player input. Okay, and you'll notice even though it's public, because we marked it as static, it's not going to show up in the inspector here. Like, it's not something that I can drag and drop in there. I'm still going to need to assign it a reference manually. So in awake, I'm just going to say player input equals get component player input. So that's going to look on this game object and return this one here that it finds. Okay. Now that we have a reference to our player input, we can actually assign these input actions here. So we can say our mouse position action is equal to our player input dot actions, open square bracket. And now in quotations, we can just grab, you can double click and Control C to copy. We're just grabbing exactly like capitals and all that stuff. The exact spelling is very important, and we're referencing it that way. Mouse action here is equal to player input dot actions. It was just mouse, right? Yeah. Okay. So now we are referencing those input actions. So now let's create an update function, and I'm going to create a couple more static variables, okay? Because I'm never going to change what they are assigned to anywhere else. I'm assigning them here one time, and they'll update every frame, but what they are referencing is never, ever, ever going to change. And I want them to be easily accessible. I don't want to have to grab a reference to Input Manager. I don't even want to necessarily use the singleton pattern for this because it's just easier to set up static variables for this. So this for that we are going to want a public static vector2, which is going to be our mouse position. Okay, we also want a public bool. I keep forgetting a public static bool was, I'm still going to call it left mouse button, but it's also going to work for touched. Okay, was left mouse button pressed. Public static bool was left mouse button released, and public static bool is left mouse pressed. Okay. Now all four of those that we just set up, we can assign them and update them in the update method. So our mouse position is going to be equal to our mouse position action dot read value vector2. Okay, so every single frame, it's going to be looking at this input action and assign it to that vector2 variable. Okay, same thing with the other three. Was left mouse button pressed, that's equal to mouse action dot was pressed this frame. Was left mouse released is equal to mouse action dot was released this frame, and is left mouse pressed is equal to mouse action dot is pressed. Okay, so that's all the code for our input manager. That's all going to update nicely. That's all going to work. Now we just need to actually go into our scripts and update the code. Okay, so instead of mouse dot blah, 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 what we're going to do here is we're going to say if input manager dot was left mouse button pressed. Here we want to replace the is pressed statement. So input manager dot is left mouse pressed and the released here. Okay, and ideally this is the kind of thing that you would set up at the start of your project, but I really didn't want to overwhelm you at the very start. So I wanted to do it in an easier way first and then refactor it later on. So we're also going to need to update anything that is pointing to our mouse's current position as well, because it will work, it just won't work with touch, that's all. So input manager dot mouse position. Okay, and I think the only other area we had that in was the slingshot area. Okay, and actually if we want to check to see did we do this anywhere else, if you find the method and you press F12 on your keyboard, that is going to open up Unity's massive input control class here, which is really scary looking. But if we click on the read value, which is what we're calling right here, right? If we click on that and we press Shift F12, it's going to show us all the scripts where we are actually calling that method. And it is in fact just this one time here. Okay, so if we replace this one, that should be good. So how can we test this to make sure that it works on mobile? So what we can do is go to Window over here, go to General, and open up Device Simulator. Okay, let's dock that over here. This is literally, you can go through a whole whack of devices here. I'm going to search for mine, which is super outdated and old now. It's the Samsung Galaxy S10. Okay, I'm going to plug that in. I want to rotate it this way, and let's actually just test it and see if it works. So over here in my game view, I don't want play maximized because that's just going to open it like this. What I want to do is play focused and then go over to simulator here and press play. Okay, and it goes back to game, go back to simulator, it's totally fine. So if it works here in the simulator, this is literally simulating a touch position. Okay, so that didn't quite work. Okay, it's detecting the touch, but it's not detecting whether I'm holding it down properly. That's because I did this code wrong over here. If we look at the slingshot handler, I've got if is left mouse button pressed, and I've got it again down here. The second one was supposed to be was left mouse button released. Okay, so let's save that and try it again. So if we go back to the simulator, now that is actually working. Now you'll notice it actually shot and I didn't release. It's not going to detect a touch if your mouse goes off the screen here. So just watch out for that, okay? So as soon as I do that, it's going to think that I released my finger. But that is working. That is a literal device simulator, so you can be pretty confident that it will be working on your phone if it's working on the simulator there. Okay, there's just a couple of things left that I want to do. I would like to get some particles spawning in when the piggies die, because having them just disappear just doesn't look all that great. So let's do that first. Then I want to actually get the camera following the bird and doing all of that great stuff. And then we're going to handle the slingshot being very elasticy. And then we'll add in some sounds at the very end. Okay, to make a particle in our hierarchy, right click, go down to effects and click particle system. Okay, that is going to spawn in what is the default really ugly particle system. It just spawns in a whole bunch of squares. Okay, this is a really complicated looking component. I promise you it is way easier to use than it looks. Okay, I am not going to go in depth into particle systems in this video. I will show you how to set up a very simple one, but I do have another video on my channel that really dives deep into particle systems and how to learn them very quickly. So I will put a link to that in the video. But okay, if you'll recall, we actually grabbed a couple of, where are they? I think it was this one. No, it was this one. Right, we cut out these 4 different smoke things. Those are what I want to use for our particle system. I just want this one to spawn in, and then this one, and then this one, and then this one here. Okay, so I would like to know if those are in order. So what's that, that, and that? Good, they are. Okay, so, and again, I'm not gonna go too into detail with all of this. I'm just gonna show you how to get this set up very quickly. It's got a duration, it's got a lifetime, which literally means how long does each individual particle system last. It gives you a start speed, all that good stuff. We don't really care about any of this stuff up here. what we care about is down here in the texture sheet animation. Okay, we're going to select that, and we want to assign individual sprites, and we've got 4 of them that we want to add in. So we'll do 4, and I think these were in order, so we're doing that guy, then the 3rd last, then the 2nd last, then this guy. Okay, so this does look like it's working. It looks a little bit weird, but it does spawn the fat guy, then it turns into the gray one, then the white one, and then finally that one. So obviously this is, I only want 1 of these to spawn in, okay? So the duration doesn't really matter what we pick, okay? 0.25, that's fine. The start lifetime, how long do we want these to actually live in the world? Let's try 0.3 seconds. Start speed is going to be 0. We don't want it to move at all. We just want it to spawn right where the piggy dies. Emission, we do not want a rate over time. We only want 1 of them to spawn in. So we're going to click here, plus on the burst, and just burst in 1, and that's going to be it. So I also don't want them spawning in a certain shape. I literally, like, you can have a circle and make them spawn in like around the outline of the circle. There's all sorts of different shapes that you can select, but I don't want them spawning in a shape whatsoever, okay? I just literally want 1 spawning in using this texture sheet animation, okay? And I don't want it looping either. So let's click play, and boom, there we go. Okay, it's 1, it's nice and quick. It comes and it goes and it disappears. That's perfect. Okay. Now, the last thing is, what do we want? We want this to play on awake. We have that set to true, which means as soon as we spawn this in, it's going to play. That is absolutely perfect. That's what we want. We also, when it stops, what is our stop action? I want to destroy it when it stops. Okay, again, this is a very, very simple game, so we're trying to do this in a simple way. We're gonna spawn it in using the instantiate method. All by itself, it's going to figure out when has it stopped, and it'll destroy itself because we selected this. So that's great. So we are going to turn this into a prefab, okay? And actually, I'd like to rename it. So double click it and click on this up here, and let's say baddie death particles. Okay, we'll click rename file, and in order to go back to the regular scene, we click on this little arrow right there. Okay, and go ahead and delete that out because we don't want that in there just yet. What we would like to do though is open up our baddie script, okay, because now we're going to want a reference to that prefab. So we're going to do serialized field, private game object, baddie death particle. So now we'll drag and drop that into our prefab, and then when he dies, before we click destroy, we are going to actually spawn in that particle. So we're going to say instantiate. What are we instantiating in? The death particle. We're going to do it at this GameObjects transform dot position with no rotation, quaternion dot identity for no rotation. Okay. So let's go ahead and drag that in. Now I said add it to the prefab. So see, I've only got 1 of these baddies selected here. If I drag and drop in the baddie death particle, that's only doing it to this 1 copy of the baddie. You'll see these other guys, they don't have it here, okay? So we've got 2 options here. We can either open up the actual prefab asset, which we do by either double clicking it here in the prefab folder, or clicking on the arrow right here. That's going to do the same thing and assign it there. Okay, oops. If we do that and we go back, you'll see that all of them now have the baddie death particles on there. Okay, but let's say we wanted to do it the other way. Delete that out. Okay, now none of them have it except for this 1 guy that I gave it to because I did that one differently, but none of the others have it now. So if I wanted to drag and drop it onto just this 1 copy, you'll notice the text here is now bold. I can actually right click that and say apply to prefab baddie. If I click that, it's no longer bold because it actually applied the changes to all of them. So any change that you do, you'll notice the position and rotation are bolded on these guys. They're bolded because they're different for all 4 of these guys. And that's exactly what we want. We want 4 copies that have different positions right? That's exactly what we want. That's perfect. But I want them all to have the same baddie death particles. So I hope that makes sense. So let's make sure that that is working. Oh, I like that a lot. That's really nice. Nice. Perfect. That looks great. Okay, let's handle the slingshot, okay? And in order to do that, I actually want you to install a new package. Now, when you installed Unity, I believe it made you create a Unity ID, okay? So what you want to do is you want to go to the Unity Asset Store. Okay. I want you to go there and I want you to search for do tween. Okay. I don't want you to buy it. I want you to find the do tween free version. Okay. This is a tweening library. And if you go beyond the beginner level, I know that there's something in your head where you want to do absolutely everything yourself, but a tweening library is something that every single professional game developer has in their back pocket. You want to have a good tweening library. Do tween is a very, very good one. So you want to click on that and you want to say, add to my assets. Okay. Once you have done that, it will apply it to your account. So once you have done that, once you go to Window and go to Package Manager over here, if you go to Packages and go to My Assets, if you do all of that correctly, you will see the tweening library in here. Here's mine, do tween, okay? We are going to, you'll have to download it first. I've already downloaded it. So now once it's been downloaded, you're going to hit Import, okay? And it's going to show you all the stuff it's importing. It's a whole lot of scripts, but it all puts them in one folder called plugins, okay? So we're going to import this. Okay, so once the import is done, you're going to see this pop up here. We're going to say open do tween utility panel, and then we're going to say setup do tween. Okay, it's going to say it's waiting for Unity to finish compiling its different scripts. Okay, so we'll go ahead and import all of these modules here. It looks like they've got a couple that are locked behind a paywall down here, but honestly, the free stuff is fantastic. And it will help you out with a whole lot of stuff, okay? So we're gonna go ahead and click apply and close that. Now we've got this plugins here, which has all of our do tween stuff in it. Okay, so I wanna keep this as simple as I possibly can. So what a tweening library essentially does is it really helps you very, very easily, smoothly move things from one place to another. And it gives you a whole bunch of functionality to make it look really, really nice. So to start, I actually need to set up a new transform under our slingshot here. So I'm going to do that under transforms, and I'm going to call this elastic transform. And we're actually going to be setting this with code, so it doesn't really matter where it goes. Okay, and let's open up our slingshot handler. Okay, so I'm going to close my slingshot methods and my Angry Bird methods, and I'm going to create a new region called animate slingshot. Now I want to create a variable for that transform that we just set up. I'm going to set a serialized field, private, don't know what that is, transform called elastic transform. Okay, so before we set up something very temporary, we put when our left mouse button is released, we call the setLines method at the center position, okay? We are going to get rid of that because we're going to be replacing it with something better, which is going to go in this region here. So we're going to set up a private void called animate slingshot. So where we just deleted that line of code before, we're now going to put that right there. So we're going to say animate slingshot here. Okay. So first I want to set the position of that elastic transform that we just created, because I said we were going to set it with code. And what I want it to be is, it doesn't matter which one, but I want it to be the first index of one of the line renderers, which is the, if we remember here, where is it? Slingshot method. The first index is the one that we actually pass in, right? Which is very, very close to where the mouse position is. So that makes sense. So we're going to say elastic transform dot position is going to be equal. I'll just choose the left one, but it really doesn't matter. which one? Left line renderer dot, and we've got this get position method, and it just wants us to pass in an index, so we'll pass in index 0. Okay, now I need to calculate the distance between where the elastic transform currently is and the center position, which is kind of where it's going to end up slinging to. And you'll see why in just a second. So I'm going to set up a local float called dist, and we'll set that equal to a vector2 dot distance, and it wants us to plug in 2 vector2s. We said the elastic transform dot position and the center position. Okay, that's going to give us one number, right? Because it's a float. Now, if you think about it, the further back you pull an elastic, the faster it's going to sling back to its original position, right? So if we don't pull it back too far, I'd actually like it to be slightly slower, but not by too much. But if we pull it back a lot further, then I would like it to be a lot faster. So we need to calculate a time variable as well. So I'm going to set up another local float. I'm going to call it time. And I'm going to set that equal to be our distance divided by, and I did some playing around with this, just like tweaked some values to see what was good, and 1.2 felt pretty good. And this is one of those cases where we probably don't want a hard-coded value in there, so at the very least we'll create a serialized field for it up here so that we can change it on the fly if it doesn't feel quite right. We'll call it elastic divider. Okay, so far all we have done is set the transform position of some random, empty transform, and then we've calculated a distance and a time, but we haven't done anything with it. So now it's time to actually use that tweening library that we just installed. So in order to use it, we're going to import using dg.tweening. Okay, that's going to give us access to all of the tweening functions from that package we just installed. So first, what I'm going to do is I'm going to use the tweening library to smoothly animate the position of this invisible elastic transform right now. And then we'll actually create another method to make sure that the line renderer follows that transform position. Okay. So we're going to say elastic transform dot do move. Okay. This is not a Unity built-in function. This is a tweening library from the doTween library. So it's built in from there. So this wants us to pass in an end value. Where are we trying to move it to? So we want to move it towards the center position, right? What is the duration? That is why we calculated time. It wants to know how long do we want it to take to get there. So we'll just pass in time. So again, we are just moving an invisible transform. So now we actually want to make sure that the line renderers keep up with that as well. So we could do this in the update method. We could do it in a coroutine. Because we are not able to use the slingshot for at least a couple of seconds after we fling a bird, I'm going to go ahead and do this in a coroutine because I think that will be a little bit easier. So I'm going to set up a private IE numerator. I'm going to call it animate slingshot lines. And again, this is just for after we've released the bird, right? So we're going to pass in a transform. We're going to call that trans, and a float, and we're going to call that time. Okay, so I'm going to set up a local float, and I'm going to call it elapsed time, and then initialize that to 0. So this is a new loop that you're about to see. This is called a while loop, okay? And you need to be careful with while loops because especially when you're a beginner, this is the easiest way to create an infinite loop that literally never, ever, ever stops running, and you'll end up freezing Unity and you'll have to, Control-Alt-Delete out of it in order to stop it. So you want to be very careful and make sure that your while loop works the way you want it to before you end up running your game. So what it's going to do is while whatever scenario is within these brackets, while that's true, this code is going to run over and over and over until it's no longer true. Okay, so we're going to say while elapsed time is less than our time that we are going to pass in when we call this function. Okay, so in order to make sure that this doesn't infinitely loop, we want to increment our elapsed time. How do we increment it? We're going to say plus equals time dot delta time. What time.delta time is, this is built in from mono behavior again. Time.delta time is the amount of time since the last frame ran. So time.delta time you will see over and over and over again in game development because it allows things to calculate and iterate no matter how fast your frame rate is. If it's going 5 frames per second, we are iterating elapsed time based on that speed. If it's going 120 frames per second, it's iterating based on that speed as well. And it's going to end up being the exact same length of time, even though it's running many, many more times. So it's very common when you have a game where you're actually moving the character by a certain move speed, you'll see it multiplied by time.delta time, because that way the character always moves at the same speed, even if your computer's frame rate is different than another computer's frame rate. If we didn't have this, then we wouldn't be able to do that. Okay, so we're incrementing elapsed time. So now we know that eventually elapsed time is going to get bigger and bigger and bigger, and eventually this while loop will not return true. Okay, but we also need to add in yield return null. What that is going to do is we're used to seeing yield return new wait for seconds and pass in a number of seconds. Yield return null, it's just going to wait for the next frame of the game. So this while loop is now acting almost like an update loop until this is no longer true. This is going to run every single frame. It's going to continue iterating our timer by the amount of time since the last frame, which is perfect. That's exactly what we want. So now what do we want to do every frame? We want to call our setLines method. It wants a position, so we're just going to go ahead and pass in our transform.position. We don't know what that transform is going to be within this method yet, so we put it in as an argument, so we'll have to figure that out when we call it. Okay, and this now needs to be called, and we'll do that after our do move here. Okay, so we're going to say start coroutine, animate slingshot lines. So what is the transform that we're passing in? We are passing in this invisible transform that we've been moving using our tweening library. I hope that makes sense. So we're passing in our elastic transform, and what is the time? We already calculated the time. It's right there. Okay, so let's check that out. That didn't work. I forgot to assign a reference again. It's just one of those things that you don't need to get mad about it. You just assign it and move on, right? So, okay, so I assigned that. Boom. So that's really, really slow. But it is animating in the proper direction, which is really, really cool. Let me see that again. It's going from wherever it was to the center position. So that's cool. We just need to tighten up the time a little bit. Okay, so one of the problems is there's one more thing that I want to add to this, okay? So this is smoothly moving it from A to B, basically, which we actually could have done ourselves very easily using a coroutine. One of the great things, it's just easier using a tweening library because we can do it with one line of code instead of something that's this long, right? But one of the other great things about a tweening library is we have ease functions. So we can say .set ease, okay? This is going to allow us to plug in a curve, basically. So you're going to see a whole bunch of different sets that we can choose from, and you can actually Google these. I know it's a little bit small, but I Googled these. This is from an old tweening library that I used to use called LeanTween. And one that I might actually be interested in trying is ease out elastic. So it's going to shoot up. It's going to go past the amount that I want it to go to, but then go back down and slowly bounce that way. So let's try ease out elastic and see how that looks. So we're going to set ease.out elastic. Okay, let's try that and see how that looks. Okay, that is looking really, really interesting. Let's look at that again. So I think it's going a little bit too far, but it is going boing, right? It's literally following that curve in terms of the motion. So it's going further than we want from the center. It's going way out here and then back down. So I don't really like that one, and I don't really like any of the other options that I was seeing either. So let's make our own curve. So what we're going to do is go up here and let's put it under slingshot stats. Sure. I'm going to say serialized field, private animation curve. This is a Unity thing, by the way, not a tweening thing. we're going to set up an animation curve and call it the elastic curve. And instead of passing in from the tweening library, instead of passing in a pre-built curve, we'll pass in one that we'll make ourselves in the inspector. Okay, so that's going to set up this right here. And as soon as you click it, this curve chart here is going to open up. So you'll see I've got a whole bunch of pre-built ones here. That's because I've made a lot over the last couple of months, and I end up just saving them in case I ever want to reuse them. But what we basically want is, at least to start off with, we want something like this one, which I think you will all have. We want something that goes from 0 to 1. Okay. Now what I actually want to do, we can right click anywhere in here and add a key. Okay. So what a key will allow us to do is start bending and curving this line. All right. So I want to try to, and I've actually got this pre-built one here, but I'll try to rebuild it again. So we want that to go above 1. We can actually edit key. We can type in a value, let's say 1.25. Okay. So we want it to shoot above 1. Now you'll notice there's these little handles as well, okay? You can click those and drag it around because now I kind of want it to bend back down this way, okay? I want it to shoot just below 1 again and then kind of bounce back up to 1 and then just be a flat line. So I'm going to add another key over here and I'm going to curve the line back this away. Maybe I'll have it shoot above 1 just for a moment. And then finally here, I'll actually edit that. I'll make sure it's a value of 1, okay? And I will flatten out that line right there. And if you're having trouble getting that, you can right click it, go to right tangent, and I think we want linear. That's right. So we're shooting up, going down below just a little bit, and then back up, and then straight to the end, okay? So let's see how that looks. It's very, very similar to this curve right here, right? We're shooting up. This one just went up way further than I wanted. Goes back down and then up and then down. The one we just made is very, very similar, but it doesn't shoot up quite as high. So let's see how that looks. Oh, I like that. That looks great. Okay, so that's looking very nice and elasticy. By the way, 2 things. You'll notice that if you play focused down here, it might not be working. If you have the simulator open over here, it wants you to be playing over there. The two seem to conflict with each other a little bit. So that was just a test to make sure that it is working for a mobile device. So we can go ahead and close that. And now everything should be working just fine over here. But you will also notice that if I win, and then I press this button here, we're actually losing a bird right there. And there's a very quick little thing that I forgot to do. We only want to allow a bird to be launched if we initially did click within an area. So there was one check that I forgot to add, okay? So this should be if we if we released the left mouse button and there's a bird on the slingshot and we also initially clicked within that area, okay? So now let's go ahead and make sure that that corrected it. Okay, perfect. So we did not lose him this time. And now the elastic is looking great on there. I love that. Okay, next let's get some sound in here, and I'm not going to show you where I downloaded them. They're going to be all in the description below. I'll put a link down there for each individual sound that I downloaded. I'm just going to go ahead and pull them into my project right now. I'm going to create a new folder for them called sounds. Okay, now for a couple of them, you will notice that they have a whole whack load of sound effects included in the file. If you're getting into game development, you are going to want to download Audacity, which is completely free. Okay, this is the best software that you're going to want to be using in order to edit your sound effects. So what you could do is open up Audacity, you just import it in, right? Okay, so this is just an example, right? This is just, I don't seem to have my downloads anymore, but literally what you can do is just drag and select around, and you can just, you know, if you find the one you want, just get rid of everything before it by highlighting it, clicking delete, and everything after, click delete, right? You can zoom in. If it's a little bit too quiet, you can press Control A to select the whole thing, go to Effect, and amplify it by a certain decibel amount. Right, this is a very, very easy software to use. So I already went ahead and chopped everything up. So first, what I want to do is set up a new script called Sound Manager. Okay, and I'm actually going to put that on top of my game manager over here and open that up. So really, I want to make it very, very easy to be able to call sounds from this sound manager. So we're going to use the singleton class again for this because we would only ever have one sound manager ever. So that's again going to be public static sound manager instance. And in our awake, we'll say if instance is equal to null, then instance equals this. Okay, that's going to allow us to very, very easily call any methods in here without needing to get component or anything like that. So we're going to set up two methods. One is going to be public void called play clip. And the other one's going to be public void play random clip. We don't know what we're playing yet, so we're going to pass in an audio clip. We'll call it clip. And we also don't know where it's going to be played from. So we're also going to pass in what is called an audio source. That is a component that you can add to GameObjects. You'll see it really soon. And we're going to add an audio source called source. Stupid Facebook, go away. Now for the play random clip, what we're going to do is basically the same thing, is audio clip, except this is going to be an array of audio clips called clips, and this will also only just have one audio source called source. So what we're going to do is say source, which is the audio source. We're going to assign its clip equal to whatever clip we pass in right here. And then we're just going to say source.play. Now for the play random clip, first we need to actually pick a random clip. So we're going to set up a local integer called random index. And we're going to make that equal to random.range. What is our random range going to be? It's going to be between 0 and the clips.length. Now, it is important to note that when you are using random.range with an integer, just want to delete this so that you can see it. It is saying as soon as we pass in an integer, it changes to max exclusive. So, okay, we're doing a range between something that is inclusive, which is 0, and up to a range that is exclusive. Okay, so it is going to exclude 1 from the length of this clip. So let's say we pass in 2 audio clips. Okay, if we pass in clips.length, that's going to return true. This is going to exclude number 2, which means this would be a range between 0 and 1, which confusingly enough is actually exactly what we want, because remember, arrays start with 0. So we want it to be between index 0 and index 1. Okay, so clips.length. Then we'll just say source.clip is equal to clips from the random index we just created. And then source.play. Okay, so that's going to make it very easy for us to just assign and play clips when we want. Okay, so let's start with the slingshot. I only have a couple of sound effects because I just want to demonstrate a couple of different ways that you might want to end up playing sound effects. So in the slingshot handler, I'm going to create a new header called sounds. Serialized field, private. We're going to put in the audio clip right here. So this will be elastic pulled clip. And then so that we use the random as well, we'll say private audio clip, and we'll make this one an array of audio clips. And we'll say elastic released clips. So if you want to follow along with me, make sure that you have at least 2 clips that you save out for the elastic released clips. Okay, so that is going to be as easy as, we only want to do it once, so we want to do it when the left mouse button was just pressed. And let's add one more check just to be safe. We're going to say if we want to make sure that there is a bird on the slingshot, so bird on slingshot. And if there is, then we will play the sound. So sound manager.instance.play clip. Okay, so we need to pass in the clip. This is going to be elastic pulled clip, and we need to pass in a source, and we have not created an audio source. Okay, so let's create a variable for that. I'll create a private audio source called audio source. We're going to put it right on the slingshot game object, so we can grab that by just doing a regular old get component call. Okay. So audio source equals get component audio source. All right, and then we will pass in our audio source right there. Okay, and then when we release it, it's going to be the same thing. Okay, we're going to say sound manager.instance.play random clip, and we're going to pass in elastic released clips at our audio source. That'll choose between at least 2 different clips there. So let's go ahead and assign everything in the inspector. Okay, so first we're going to want to add component and add in an audio source to our slingshot. Now we do not want anything to play on awake because it has no clip assigned to it yet. All right, so we'll just minimize that. And now we'll go ahead and assign these here. So I like to do it by just opening that up by clicking properties, go to sounds. I'm going to add in these 2 elastic plucks for the released clips, right? Now they're there. And then leather pulled, that one there. And let's test that. Okay, let's make sure it does it again. All right, I heard at least 2 different sound effects for when I released it, so that's working. So I want to just add 2 more sound effects into the game. I don't want to make this too complicated, but I do want to show you a couple of different scenarios, and I just want to make it look and feel nice. So I want to also add an audio source onto our Angry Bird, because I would like to have him make a sound whenever he hits anything. So again, we're going to take off play on awake. Okay, open up our Angry Bird script. Let's go ahead and assign that up here. Audio clip, hit clip. Okay, and we'll need to set up an audio source as well. Private audio source. We'll assign that with get component. Audio source equals get component audio source. And then we're just going to make it play a sound whenever he collides with something. And by the way, I'll get rid of that there because I completely forgot about that. So I just want to show you that in a second. But sound manager.instance.play clip. Passing in the hit clip and the audio source. Okay, and I had a line of code there that I did behind the scenes. I also want to destroy this script as soon as the bird touches anything, because remember, fixed update runs every 0.02 seconds, and it's just doing a whole bunch of if checks. Even after we've hit the ground, we set this to false, which means that this won't run, but it's still doing the checks every single fixed update. So it's just kind of a waste of resources. So what we can actually do is just destroy, not the game object, but destroy this, meaning this script as soon as we collide with anything. We don't need anything running on this bird after we have played the sound, right? We don't need to do anything else. So we'll just destroy this script and save a little bit of resources that way. Okay, so let's go ahead and assign that clip. I'm gonna put in my hidden box. Let's make sure that's working. Cool. Okay, and I would also like to play the pop on the baddies when they die. Now, this one needs to be done a little bit different. Let me tell you why. When the piggy dies, we are destroying the whole game object, okay? What that means is if we have an audio source on the baddie here, that audio source, along with all these other components, the entire game object is going to get removed from the game. That means if we had a sound that was in the middle of playing, if the game object gets destroyed, the sound stops playing. So that's not going to work. So let me show you another way to play sound effects, okay? We actually do not need to add an audio source to this guy, but we still need a reference to the clip. So let's grab that. Serialized field, private audio clip, death clip. Okay, so right before we destroy him, what we're gonna do is say, we're gonna reference the audio source because there is a function within that class that we can use called play clip at point, okay? Now it wants us to pass in a clip. So we're gonna pass in our death clip. And at what position? We'll do it at this baddie's transform.position, okay? So what this is actually going to do is it's going to spawn in an invisible game object into the game with its own audio source. It's going to play that, and then it's going to destroy itself after the sound effect has finished playing. It's a really, really useful function. So I'm going to add pop in there, and we're going to right click and apply that to our prefab instance so that it happens for all the baddies, not just the one. And let's test that. Awesome. Okay. The next thing I want to do is actually handle the camera, okay? And we need to install another Unity package for this, and it's going to be called Cinemachine, all right? This is from the Unity registry. You don't need to go to the asset store. This is built into the Unity engine. It just doesn't come pre-installed. So we're going to go ahead and install that. If you are doing anything with your camera in your game, you're going to want Cinemachine with Unity. It is a really, really phenomenal way in order to get camera stuff following your player and doing a whole bunch of fancy transitions and things like that. And there's really not a lot of code required in order to do it. So it really simplifies what we used to have to do in a very manual way and code it all ourselves. Cinemachine really simplified the whole process, which I love it. Okay, so once that's done, what we're going to do is right click in our hierarchy. We're going to go down to Cinemachine, which is there now, and we're going to add a 2D camera. Okay, now this might be a little bit unintuitive, but when you're working with Cinemachine, we're actually going to end up having multiple virtual cameras in our game. Only one of them is ever going to be active at the same time. You'll see that our game disappeared. Don't panic, okay? Just put -10 back in your transform position if it zeroed it out, okay? So what actually happens here is as soon as we create a virtual camera, that starts driving all of the values of our main camera. I can no longer change the size right here. I can't do anything with my transform position. It's all being driven by the virtual camera here, okay? So now if I want to zoom my game in or out, it's going to be done on the virtual camera, not the main camera. Okay, so I'm actually going to create a new empty called cameras. I'm going to bring it to the top because we're going to wind up having a couple of different cameras. So put our main camera on there and our virtual camera on there as well. So I'm going to call this first one idle camera. And I'm just going to change the orthographic size to 6 so that I can actually, not see the borders. And I'm going to duplicate that, and I'm going to call this one follow camera. So I said each Cinemachine camera, there's only ever one live at a time. It actually tells you right here. Right now, this one is live. Why is it this one? Because whichever one was enabled last is the one that is live, okay? So if I go over here, this one's on standby. If I disable it and enable it, now this is the one that's live, and this one over here is on standby. So that's important to know because all we have to do is simply flip which one is enabled with our code when we want to switch between them. Now, Cinemachine is awesome. You will see this weird little icon that got added to our main camera here. That is because it added what is called the Cinemachine brain component to our main camera. So that is going to take care of a whole lot of the transitions and things like that. Literally, all we have to do is swap between these cameras with some very simple code, and the Cinemachine brain is going to handle the transitions between the two cameras. It's going to do it smoothly, and it's going to look really nice. But we do need to control all of this with code, so I am going to set up a camera manager script. Okay, so I'm going to go ahead and add that to my cameras up here and open that up. Okay, so all I want to do is initialize which camera I want to be active first, because I really don't want to be doing that in the inspector. I want to do it with code. And then I want to set up a method that will allow us to switch between the two cameras. So first, let's grab a reference to those two cameras. And now that Cinemachine is installed, we need to add it as a namespace in order to reference its components. So we'll add using Cinemachine up here. That will allow us to grab a private Cinemachine virtual camera, if I can spell it right, Cinemachine virtual camera. We'll do an idle cam. Virtual camera, follow cam. Okay. So in our awake, then I'm going to want to determine which one is going to be active. So I'm just going to set up two very simple methods. One's going to be a public void switch to idle cam. This one's literally going to say idle cam dot enabled is equal to true, and follow cam enabled is equal to false. And we're going to do a public void switch to follow cam. Same thing, only backwards. Follow cam dot enabled is equal to true, and idle cam dot enabled is equal to false. Okay, so in our awake method, I always want to start off with the idle camera. So we will say switch to idle camera in the awake function. So now we just need to actually call this in another place as well, but also call this one here. So let's go to our slingshot handler and let's get a reference to our camera manager. And let's just do it the easy way this time and say serialized field, private camera manager. So before I forget, I'm going to go ahead and assign that now. So slingshot and just drag in the game object that script is attached to, okay? So we want to go down here to our update function. Now I actually want to switch to our follow camera as soon as we are dragging our bird around on the slingshot, okay? So actually right here is perfect. Right where we play our clip, I'm going to say camera manager dot switch to follow cam. So when do we want to switch it back to the idle camera? Well, remember, we actually spawn a new Angry Bird after a certain amount of time. So that would actually be the perfect time right after this time has happened, okay? So right after we spawn an Angry Bird, we will go ahead and say camera manager dot switch to idle camera. Let's test that. I remembered to assign it in the slingshot, but I forgot to assign it in the actual cameras here. So we want to grab the idle virtual camera there and the follow virtual camera there in the cameras script, okay? So it's on the idle camera, everything looks normal, but as soon as that's not working, oh, I know why. It actually is working. It's just I forgot something very important. I need to actually assign what in the heck this camera is following, okay? And I don't really want to do that in the inspector. I would rather do it with code because that makes it easier to do if we want to build multiple levels and stuff like that. So actually in this switch to follow cam, what we will do is pass in a transform because right here, right now, we don't know what transform it's going to be. So we'll just call it follow transform. And before we enable the follow camera, we'll actually pass in what is it following. It's going to follow the follow transform. Okay, so you'll see that'll give us an error because now we need to actually pass something in to the switch to follow cam here. What do we want to pass in? We want to pass in the spawned Angry Bird. And if we remember, that is of type Angry Bird. So that won't work, but we can say that dot transform is what we're looking for. So now that should actually assign our Angry Bird to the follow position. So let's try that next. Okay, there we go. It's following him around. That looks great, except for the fact that we can see outside of the border there. So we'll address that in just a second. But you'll see that when we let go, okay, it's following him around and everything's looking pretty good. Now, if you are seeing any weird lines in your tiling like I am right here, I'm going to show you a quick little trick to get rid of those because those are driving me nuts. So I'm actually going to go over here and I'm going to go to Create 2D Sprite Atlas. Okay. And I just want to drag in these three tiled assets that we were using. Just drag those in there. Okay, let's see how that looks right now. That looks probably worse. So what I want to make sure that I do is go back into the sprite editor, and I just want to make sure that, yeah, I don't want to be going past anything transparent there. I'm going to go that way, and I'm also going to go one more over on this side as well and see how that looks. I'm going to click apply. There we go. That got rid of any weird slicing issues. That's all looking much better now. Okay, so now that that is fixed, I noticed another issue when we pull this guy back and we put him over there. Okay, now our elastic is gone. That wasn't happening before. And so I was reading through the documentation on the tweening library, and we actually need to go over here in our spawn Angry Bird method, and we need to pass in our elastic transform, right? Because remember, that was the transform that we were actually tweening, and just say do complete. Okay, what that's going to do is actually complete any tweenings that were being done on this transform so that they don't end up fighting with each other. So let's make sure that that fixed it. And actually, one more thing. I don't want our follow camera to be having the Angry Bird exactly in the center of the screen. I don't like that too much. So it's going to assign the follow, but down here in the body, I would like to go down to the screen X and maybe change it to, is that the right way? 0.45, let's check. Yeah, so it's just looking ahead a little bit. Yeah, let's set that to 0.4 and see what that does. Yeah, so it's keeping all the piggies on the right side a little bit more on the screen, which is more what I would prefer. So that's looking pretty good. Okay, so now let's actually make sure that our camera cannot go outside of the border. Okay, so we can actually add an extension here called Cinemachine Confiner 2D, and it wants a bounding shape in the form of a collider, okay? So what we're gonna do is add an empty under cameras, and we're gonna call it boundary, camera boundary. Okay, and we're going to add a box collider 2D, and it needs to be a trigger, otherwise it's gonna cause all kinds of problems, okay? Actually, I'll put this on its own layer as it should be. I'll call this camera boundary. Put it on there. And now I also want to add a composite collider 2D, okay? So the reason I want to do that is because the follow camera, this is only going to accept a collider that either has a polygon collider or a composite collider 2D. I just know that from experience. I don't like polygon colliders. You can try them out if you want. I really don't like working with them though. But composite colliders, what they allow you to do is have multiple box collider 2Ds or other types of 2D colliders and composite them together into one colliding shape, okay? Now, the other thing we need to do is make sure that the composite collider is actually the first component on this game object, okay? Because as soon as we assign this game object to the follow camera, it's just going to find the first 2D collider that it finds. We don't want that to be box collider. We want it to be the composite collider, okay? So down here in the box collider, we're going to say used by composite, okay? That's going to get rid of some options because now it is being controlled by this. So now we want to make sure that it's set to trigger from here. Okay, we want to make sure that we change the geometry type to polygons. And we can change the rigid body. When you add a composite collider to things, it has to have a rigid body. It automatically adds it. You can just change that to static because we obviously don't want gravity or anything like that on this composite collider, but composite colliders come with rigid bodies. So we'll just leave that there as static. Okay, now in our follow camera, we'll add our camera boundary in there. Okay, now let's actually size this to be the way that we want, because right now it's really, really tiny. So I'm literally just going to make it go all the way over here to where the ground ends, and same on the right side. We'll adjust the height based on some testing in just a moment. Okay, so you will see, let's try it. Hey, I hope that transition was not too jarring for you. This is actually Brandon from editing speaking to you right now. Hello. So this part of the tutorial actually, I ended up having a bug that I encountered. So I'm just re-recording it because it was not going over well in the editing for me. And I want you guys to have a really good experience. So we're trying to set our camera boundary right now. And this is where I encountered a bug. I'm not entirely sure what the issue was, but I did find at this point in my project, I had to go back to edit and go to project settings. And over in the editor tab here, I had to go back down and disable enter play mode options because for reasons that are unknown to me right now, that was giving me issues with trying to get this boundary to work properly. I'm not entirely sure what that is. It might just be the specific version of Unity that I'm on right now, and it might get patched out. I wasn't able to find out any information online though, so it's unknown to me right now as to why, but I had to turn that off. So I recommend that you do the same at this point just in case, because I don't want you to run into anything that's really frustrating for you. So let me show you how we're actually going to fit this camera boundary here. So earlier in the tutorial, I had you turn off the sky here, I believe, and we never actually turned it back on. So at this part, it would be useful to be able to see that again. So down in our environment, if you have that little eye icon disabled, just go ahead and click it, and let's bring our sky back in our scene view, okay? I also had you disable gizmos up here in the scene view because they can sometimes be a little bit annoying, but in this scenario, they're really, really helpful. So turn those back on. And what you're going to see is this little white box that pops up into our scene view. That is called the camera frustum. And that's just a fancy way of saying basically this is what the camera is seeing for the game view, right? And you can actually tell this is exactly this game window right here. So what we're wanting to do basically is just assign this camera boundary and size it in a way that it doesn't, we don't want it to go above our sky here, because then of course, if we do that, what's going to happen is when we play, our bird will go a little bit above the sky and we'll see out of bounds, which we don't want to be able to see, right? So you can see that right now. But as soon as we tighten that up and we bring that back down, and this is why I wanted you to be able to see the sky, because we'll just bring it right there. And it's the exact same with our ground. We just want to bring it right to the border, but we do not want it to go beyond. And I'll actually play in focused mode because you'll actually be able to see this white box. It will not go beyond that boundary that we just set. It's really cool, right? So as soon as we hit follow, even when I drag him down, it goes right to the bottom of the ground, but it will not go beyond that. And same for even if I shoot directly up, right? It stops right there, which is exactly what we want. So I just wanted to make sure that you enabled, that you changed those settings in the edit, that you turned your sky back on so that you could see it, and turned your gizmos back on, because that makes this process very, very easy. So that is how we are making sure that the camera border fits inside of our camera boundary box collider 2D. Okay, so I'll bring back regular Brandon. Bye. It takes a couple of seconds to actually load the game now, which isn't really my favorite, but it is actually not going above where I want it to go. It's following him on the X. He'll come down, right? But it's never going outside of our level boundary, which is fantastic. And then it just swoops back. But our elastic is still not there. Why not? And this is where debugged log statements still come in really, really, really handy, okay? So I wanted to see what was happening in here. So inside of our animate slingshot lines coroutine in the while loop, because that is running every single frame, let's just throw in a debug.log and say, this is running. If If you're ever trying to solve a problem online, a lot of the people are going to ask you, have you debug.logged, different parts of your code to see what's running. So I don't want to run this on maximize. I want to run it on focused. So that's going to run and print a log in here every single frame while the lines are being animated. Okay, so I'm going to draw that back and pull it up. It's running, it's running, it's running, it's running. It's still running even after the Angry Bird has spawned in, okay? It ended up running 418 times. So the reason our elastic is not being drawn back here is because that coroutine is still running even after our Angry Birds has spawned in, okay? So that's based on the amount of time that we passed in. So I have an idea. What we're gonna do is go up here to slingshot stats, and we're going to say serialized field, private float, max animation time. Just gonna give it 1 second, okay? The max animation time is 1. So everything in this while loop is going to run while this is true. So we want it to run while the elapsed time is less than time, and the elapsed time is less than max animation time. Okay, we pass that in as 1 second. Let's test that out. Okay, pull that back as far as it goes. Boom. Okay, that didn't seem to be an issue this time. So now that loop is really, it's going to max out at 1 second because it's a very, very, very short animation. So it keeps on going because our math calculation that we did ended up being obviously a little bit longer than I thought. So this is one way that you can handle that. Let's get rid of that debug log statement. Okay, now one last thing that we need to fix is when we restart the scene, sometimes you will see this warning message right here, target or field is missing or null. Okay, so it's saying that something that we referenced has been destroyed, and it's a message from tween. And the best way that I found to clear that is in the game manager when we are calling, where is it? When we are restarting the game, oh, it's in here. When we are restarting the game, we are going to say, oh, we need to add our namespace for the tweening library at the top. So we're going to say using bg.tweening. And we're going to go down and we're going to say dotween.clear. Okay, and we want to actually destroy the tweening game object, because whenever we use a tween, it actually ends up instantiating a game object into our scene that holds a whole bunch of the tween code on it. So whenever we restart our game, I just want to clear that out so that it's not trying to reference anything. So let's make sure that that gets rid of that error message. Perfect. Okay, and this would be a little bit disappointing if we didn't at least add the ability to create new levels within the game. Now I'm going to do this in a very, very, very simple way that really you wouldn't want to use for many games. But again, for a game that's really simple like this, where basically nothing is changing except for, the blocks and the piggies that you end up putting in the level, the way we're going to do it here is completely fine. But again, I don't want to go too outside the scope of just a beginner level tutorial. But what I am going to do is I want to temporarily open up my restart screen here, and I want to add in one more button. Okay, I'm going to move our restart icon over. I want to duplicate that, move that one over here, and we're just going to give ourselves the option to load in a new level. Okay, so I'm going to need to grab another sprite from that, from the buttons sheet. And I would use this guy, except he's got a shadow there, which is probably going to end up looking a little bit weird. So I'll just use this guy instead. Okay, we'll apply that. And I'll drag that in. And we'll call that next level. Okay, and when we click the next level, we do not want to click restart game. We want a different function. So we're going to create in our game manager another function called public void next level. Actually, I want to get a reference to that image specifically. So we're going to need to do the using Unity engine.ui namespace. Serialized field private image next level image. Okay, so we'll do something with that in just a second, but for the next level, all we want to do is say scene manager dot load scene. What scene do we want to load? We want to do scene manager dot get active scene dot build index +1. Whatever the next one is in the build index, right? Now how we're going to control this, because we're only going to have a finite number of levels, so we don't want to try calling this when there isn't another level. So what we'll do is we'll put a check for that in our win game. So we'll create an int for our current scene index equals scene manager dot get active scene dot build index. And we'll create another int called max levels. That's going to be our scene manager dot scene count in build settings. Okay, and we'll say if current scene index is less than the max levels, meaning there's still another level that can be loaded, then we'll actually enable that image. So next level image dot enabled equals true. And let's make sure that's set to false at the start of the game. Let's make sure we set that to false. Okay, so we want to make sure that our next level is set to game manager next level. And we want to make sure that in our game manager, we have assigned next level to our next level image. So currently, this should not work because in our build settings, we only have one scene in there. So right now, let me make sure I turn that off. Right now, that button should not show up. And one last thing that I forgot, the current scene index is going to return an index of 0 because it's an array of scenes. It's going to return 0, but the scene count in build settings is going to return the count of the number of scenes. So even right now, it's going to be 1. So we actually want to do if the current scene index +1 is less than the max levels, okay, in order for this to work the way that we want. Okay, great. It did not show up this time. So let's create a new scene. So let's go to our scenes folder, and I'm just gonna Control D and duplicate this scene. We'll call this scene 2. So let's go back to sample scene, and let's go to file and go to build settings and add scene 2, drag and drop it into our build settings up there. So really quick, I'm just gonna set up something that's a little bit different. This might all come crashing down. I don't really know. This level's actually easier, but anyways, you get the point. Let's go ahead and save that. Go back to our sample scene and try that again, just to show you that it's working. I'm gonna have to do better than that. Boom, perfect. Okay, so let's go to our next one. Boom, there you go. New scene has been set up. And if we beat this one, it does not display that new button because there are no more levels to be added into the game. So we can click that one and restart it, but that is it. Okay, so that's about it, guys. I really wanted to make it so that you can create a few more levels to make this more interesting for yourself. Now, if you want to publish this to Android, okay, there's really very, very simple instructions that you need to do. Right now in our build settings, by default, it's going to be set to Windows, Mac, and Linux. you probably have a grayed out Android or iOS option. Okay. And again, if you have an Apple device, you're going to want to do a little bit more research because I think that you need some sort of Apple account in order to publish to Apple devices. I don't really know how it works. I don't have an Apple phone, so I don't have a lot of experience with that, but I do know that with Android, it's very easy. So if Android is grayed out for you, you will have the option to install the Android platform via the Unity Hub. So you can go ahead and do that, and then you'll need to restart the editor. Once you have done that, you'll have this Android over here. You can then click Switch Platform. That's going to switch it to the Android. It's going to take a minute to build everything. But literally, when you are done, whether you're on Windows, if you want to build a PC version, or whether you're on Android, whichever one you switch to, you're just going to go ahead and click the build button. It'll ask you to create a folder. You can save it in there. You can build your game. And if you build it to Android, go ahead and upload it to whatever, email it to yourself or upload it to Google Drive, download it on your phone, install it and run it. And it's just going to work. It's really, really awesome. And that's it, guys. This was originally going to be a very, very short tutorial, and it ended up just kind of going way beyond what I expected. So this was a lot of work to put together. So, if you want to show support, we have a Patreon account. If you can afford it, please. If you are wanting to show some financial support, we have a Patreon account. There's always YouTube thanks. We just opened up a merch shop actually. So there's a bunch of different ways that you can support us, but definitely please like this video if you found it helpful, if you liked it, if you want to see more of this type of content. Liking it definitely does help the YouTube algorithm push it out to more and more people. So if you're looking for a free way to pay me back, you can do that with a thumbs up. I really hope you enjoyed. I know that this was a long tutorial, but I know that it's really magical the first time that you're opening up your game engine and you're actually creating a game. So I wanted this to be a very fun, cozy experience for you. I didn't want it to feel rushed or stressful. I even ran into some problems that I was not expecting, so you kind of got to see me fixing some stuff on the fly. I really, really hope you enjoyed, guys. And if you are just starting out your game development journey, I wish you the best of luck. I have lots of other tutorials on my channel that can help you get going. Not all of it is beginner friendly, but some of it definitely is. So you'll just want to scroll through and check that out. But again, like I mentioned earlier on in this video, you just want to practice. You just want to keep on building stuff. So if you are looking for my recommendation for what you should do next, if this was literally, and I expect it was, if this was literally your first time inside of a game engine, what I would recommend that you do is you try to create your own game now. This is a very long tutorial, so you should now be very familiar with the Unity engine. You should be familiar enough with some code in order to be able to do a couple of things yourself. And if you literally have to Google for every single line of code how to do something, that's normal. That is okay. That is where we all started off. What I would recommend though is Flappy Bird. Flappy Bird is a really, really fantastic game to try to make by yourself because there's very little involved in doing that. And I'll give you a little tip. Make the pipes move. Don't make the bird move. That's going to make your life way, way easier. And you just make the bird, kind of jump up and down. You know how to do add force, so you know how to do that. But yeah, that would be my recommendation, is trying to do that next and trying to do it without following a tutorial to do it. I would recommend that you do that and try to do it on your own. Use Google as much as you want. Use ChatGPT, if you really, not to spit out code for you, but to ask it questions in terms of what you should do next. ChatGPT can actually be very helpful. It's a great tool. But yeah, actually problem solving, researching, and figuring it out as you go is the best next step, because that's really going to help you level up with your game dev skills. Anyways, guys, I really, really hope you enjoyed this video. Again, give it a like if you found it helpful, and I will see you in the next one. Bye.